before eYantra, what I used to do apart from the studies was totally unorganized. But when I participated in eYantra, they gave me, structured way of learning. From now onwards, if I will get a new problem, my approach won't be a hit and trial way. It will be of more systematic way.
We actually got to integrate something mechanical hardware thing with software. So usually most of our projects was either just hardware or just software. So we thought just building those parallelly, and in the end getting it together will just make the thing work. But actually we learned that we have to do everything step by step. Even if it's software and hardware, they're not totally independent. Everything needs to be done step by step, test if it's working, and then keep going forward.
In mechanical aspects, we tried to design the bot at first and we failed badly. So somehow interdisciplinary subjects were being taught to our brain, or like we were fed indirectly and we were practicing them. So that failure actually helped us to do stuff very good. We learned how to start from scratch, building things up and how they are working at the back end. So that's the main plus point we get in here. And this also gets in the interest. Rather than just theory, we have the practical stuff going on.
For the electronics, PID is taught theoretically in control system. But when you actually implement in eYRC, you actually see what you were learning theoretically in the classroom.
Many people have a fear in doing a actual physical robot, the hardware, because in simulation everything works. But when you are implementing something in hardware, there is a very big challenges that you face that you cannot predict. So after this entire eYantra competition, I feel that I am very much confident in taking on any hardware projects head on.
When you attend daily lectures, if you go to colleges, so you'll be seeing a theoretical explanation of the topics. But when it comes to eYantra, it's a top-down methodology where you will learn things and you'll be implementing it right away to check if it works or not. And that's how it also stands up against other robotic competitions, like where there will be only one thing, like you'll be going with your implementation and you'll be participating. But eYantra is like, it helps you learn. It teaches you first and then it will check which was a better implementation. So for me, I think eYantra is a great way of and a better way of learning.
Before I joined this robotics competition, if you had told me that we were working on a project during my final exams, I wouldn't have believed you. But this robotics competition has taught me that you can really work hard and just like really push me out of my comfort zone.
If you tell someone that we work till 10, 11 in college, they'll be like, no, I can't do that. Why would I do that? But then this is really satisfying when you get positive results, when you get selected, when you score in one of the highest in the number of teams. It's really satisfying. You feel that it has paid off. Like me working more and leaving out the luxury I had, like simply goofing around and not doing anything, it really paid off. Before this, I used to, like, if I get some problem in some coding stuff, I used to like get demotivated and then just leave it, like, okay, I'll get back to this later and then focus on other things. I had literally no time management. Like, I had no timing about what to do when, like, if I didn't have deadlines, it would take a lot of time for me to submit something. Because of this, I became like more punctual about submitting stuff on time and finishing it properly, and like it should be working exactly in all situations.
Till now, whatever competitions or hackathons that we have attended,
we have not really found that that sort of an experience where you're also learning in the process. You're just usually applying whatever you know, and usually it's more of a test of how much you knew before. Here it's more about how you can come up, and creativity and all that comes in. And also the hardware platform was completely unified across all teams.
You don't have time, you make time. So like once you are inside this eYantra, eYantra is just gonna compensate for the free time. You're gonna have more fun than you had in free time. Like working with the new stuff that you get, the kit that they give, and like just solving these challenges have been more enjoyable and fun to work with.
eYantra Robotics Competition broadens your, like it helps you look at various disciplines and integrate them together at the same time. Because as I said, we were pre-eYantra very limited to CS, and we were not seeing outside our own branch. We used to think that electronics, we are not much interested. Why should we look at that? But now, since this robotics has a very huge, like a broad, wide area of working. We have to know how to integrate these smaller things, and we have to eventually learn a lot of other skills which are not particularly in your branch. And I feel like a lot of engineers must know this if they want to be particularly good at their applied field.
eYantra is life-changing for me. We saw that like even the minutest thing that you like did in the first task and you think like, oh, that's never gonna happen, and that really came to bite us back later towards the end. So this has really fundamentally like changed the way, like at least I have started like coding and solving problems, and I think I can confidently say that I am a better problem solver right now.
I've never done anything like this before. I was only aware of designing stuff and all these things such as the PCB designing, PCB manufacturing, as well as the electronics part is very much new to me. For me, it is more than just a competition. It's a place where you can learn new things. Sometimes even some people can't afford this electronic stuff, and they are having those interest, but they can't afford it. That's why they pass it on. So if you take part in eYantra, so they provide a lot of things, and the guidance is also very great, sir. We had regular discussions on Piazza and all that stuff. Thinking has been changed. Prior to 1 year, if someone have said that you have to make a fish or a robot which can move underwater, I would have said no, that's not possible for me.
I was a leader. Some of my leadership qualities also improved. Other than that, technically it was a blast. We had to learn a lot of new things and apply things that we had learned in creative and innovative manner. eYantra themes are designed in a way in which we have to think outside the box and be creative to get a good solution to what they have posed as a problem.
Our college staff told us that eYantra competition is there, but they told us that you form a team which will consist of computer guy, electrical guy and electronics guy. We form a team of all the mechanical guys. So actually they were not allowing us to participate. They were saying that you will not do the up to the marks, and due to that our confidence was lost that we can't do that. But actually we taken the decision to participate, and we forcefully participated by requesting our HOD and our mentors. So they allowed us because they were knowing that we can do that. We were not having the confidence at that we will go to the finals actually. But as we were started working, our confidence was getting increased and increased and increased. And as we came up with our 3D design, we got the confidence that we can do this.
Generally, as an engineer, if we are given any assignment or something, workshop or project, generally in third year, fourth year. So what we have a habit of doing, we just go on Google and search something like a third year project, assignment, something like boiler, and then we just copy paste the same thing. So here in eYantra, after we are having the theme, very first thing we did was we didn't start surfing over the internet. For example, we were having a fish theme. So what we started was thinking about the design from the very basic perspective and learning from the nature itself. So it was a good thing and nice thing for our learning and widening our thinking horizons. So it was good that we were now able to think about the problem and the solution.
The main soft skill that we learned was teamwork. Along with teamwork comes adaptability, that we have to adapt ourselves to different situations. Coming to situations, we had internal disputes, internal disagreements, and we had to resolve it using each other's opinions. Time management, responsibility, adaptability, communication skills, and problem solving skills were all the soft skills that we imbibed during this journey.
It helped me to improve my soft skills and my conversation skills, first of all, because building a project and presenting a project, they are completely different. So it helped me improve my skills like that.
Whenever an industry person visits our college, he is also visiting our lab, and we are the first one who are put forward before them, and we are able to interact with them. It has also helped in our interpersonal skill, and our communication skills are also improved.
Soft skills that I learned from eYRC projects are that mainly to keep calm in the most worst situation instead of panicking. For example, today itself in the competition, one problem arose to us, and in that situation, from that situation, we learned how to keep calm. Another soft skill it taught me is that the presentation, how to present the things beautifully. Actually, I am from the hardware. I have worked for hardware. So in that hardware, there are many wires and all, and how to present them, mainly that we learned it from eYRC. My confidence was very low. I was not that much confident while speaking in front of the camera or in front of the people, but from this competition, I learned all those things.
I also learned many qualities like leadership actually. I was the leader of the team actually. Before this, I have not been a leader, or I don't have confidence to lead a team. But here I learned how to coordinate my team and how to get work from them.
At the first time, I had zero level confidence. By entering this eYantra competition, I gained a lot of confidence. It helped me build communication skills. It helped me present myself in a better way.
Taking part in the eYantra's idea competition has made me really disciplined. The weekly schedule for the coursework plus the deadlines for the round 1 and round 2 submissions really made me disciplined about how and when I should be finishing my work. It helped me finish my final year project earlier and even made it better than before. So such type of competitions will not only boost your confidence, but it will also give you an exposure to a unique type of learning which is very lacking in India, that is the experiential learning. So I would encourage anyone to join eYantra's ideas competition for the next cohort.
It created a, you can say, an impact on me, because all the things that are carried out through this competition as well as in the internship have affected my life a lot. My focused shift from the comfort zone towards a zone where I can explore more things. in my life, what the change I feel is the confidence I'm getting from eYantra to stand before and speak in a technical language with all the people or with someone who is talking to me in that field. I've improved myself in coding with the help of eYantra only. I've started focusing and getting interested in it more and more as I am exploring it.
I was having problem with the peer pressure. I was not able to give a speech or a video to anyone in public, so I was having that peer pressure. Before I was like not talking publicly to anyone, like not having a stage daring. I even can't speak a word. I just leave the stage, and that was issue. In some tasks we need to make introduction videos. In that videos it was like we took hundreds of take to make a successful one take video. So due to this I'm that confident to speak among the people. I'm in electronics engineering and I am confused like to do with computer applications like coding and that, or should I go in electronics section like hardware, power supply and that. So in eYantra I got that idea that I can go with both of them.
It is like a culture for me. Why I'm saying culture? Because I want to place one quote. When experts are being built, they are first a beginner. And as we are beginners, we are in perfect hands, we think, with eYRC. Because for being getting introduced to all these things, no other platform will teach us to go with the basics, or it will ask us that first complete your basic levels and then come to us. They'll give directly one problem statement, but that was not with eYRC. As they started with VRAP simulation, then they actually came on hardware testing, and then they gave us the platform to start working with the real bot. They are building us like a family. What our family members do for us, that they always think how we can go forward and do things, how this our children can get benefit. The same thing eYRC also does. I will say that no other company will give this chance to us to get such sessions carried out in the internship. They will just provide us the statements and all the problem work we have to do for them, and they will say start with your job. But that was not with eYRC. Definitely, they have boosted us a lot.
First year when I actually missed eYantra, it was because of the time constraints, because we couldn't complete the project in time. So it actually taught me how to actually manage my time. And the second year, I just took some of my friends in the team who I thought would be great fit for the team, and it would be a lot of fun working on the project. But I didn't actually know how to build a team or how to manage a team. So that's the second thing I analyzed why we failed. I didn't have the team building quality. So in the second year, I learned team building qualities from eYantra. And this year, I had the perfect team. We managed the time well, and that's why I believe we reached the finals. But this year also, it taught me a lot of things. That is to expect the unexpected and always have a backup. In case things go wrong, in case your bot breaks, you should have a backup. So each year, eYantra does not, just allows you to learn something that's technical, the robotics. It allows you to actually learn something and develop yourself as a person more and also as an engineer. But more than that, it gives you values that you can keep with yourself for a lifetime.
I'm from CSE background. I was like afraid from doing hardware stuff and everything like that. Earlier, I was like, I should not participate in this competition, but then I overcame my fear. I said I should learn something new. So I learned about hardware a lot, which earlier lacked in my profile. eYantra basically builds the perseverance in you. Our team falls twice, we stood up thrice. So that was the thing that eYantra taught us.
We have gone to various competitions, but none of them have been like that. We are staying in the college like for 2 days straight not like not sleeping, just working at it actually builds your team. And we three are like also because of our friendship, we are actually going for a startup actually also. So Yantra has inspired us in doing various activities as well.
You have to design a mechanical structure that is to be fitted in the bot. So instead of making it sort of in a makeshift way, you should actually use the tools that are designed for the purpose, a laser cutter or a CNC machine, to actually properly design it or 3D print it. So and you should actually model the system. So we learn to look things from a engineering point of view than hit and trial point of view.
Deepa ma'am's queue, we can start.
So is Nirikshak Bot. Aditya?
Nirikshak Bot, yeah.
Nirikshak, okay.
Yeah. Inspector, yeah.
Okay. We've given it classical names, Hindi names this time. Right? We are slowly becoming more local. Incidentally, this competition went international since last year, and we were delighted to have a team from Bangladesh in the finals this year, right? So that's another story. We'll speak about it later. So we are live. Great. May I start? Deepa,
Yes, sir.
please. Okay.
Sir, we can start.
Great. So welcome everyone to yet another day, the fourth day of 5 of the eYantra Robotics Competition 2020-21, where we have yet a very interesting control systems based theme here for you. It's called Nirikshak Bot, which is an inspection bot. So this theme is based on a balancing bot concept, where we teach you control systems and stuff like that. And the idea is inspired from an Industry 4.0 scenario, where we have to have an inspection bot, and that inspection bot has to check whether some balls pass a quality test using a variety of tables. So in this, we are privileged to have with us some very interesting members of jury here. Let me start with Professor Kriti Ramamritam first. He is a colleague from Computer Science Department who's recently retired, and he's in Chennai at the moment. He's a BTech, MTech from IIT Madras and PhD from University of Utah. And he's one of the most cited computer scientists in the country, with his research interests encompassing things like database systems, real-time computing, sensor networks, smart energy systems, mobile computing, and you name it. And he spent a long time at the University of Massachusetts before he joined IIT. I think he's been chair professor in both these institutions for almost equal time. He's very decorated fellow of IEEE, Indian Academy of Sciences, Indian National Academy of Engineering, editorial board of the top journals, and he served as Dean R&D at IIT Bombay, and he's a distinguished alumnus from IIT Madras, and recently he got the Lifetime Achievement Award from IIT Bombay. But the reason why Kriti is important is that we used to teach a course together, CS 684 Embedded Systems, and part of that course was a project. And from the project aspect of that course, when we needed to teach this course through the distance education program of IIT Bombay, we found that it was very difficult to teach it, because through the distance education paradigm, we could only teach theory. So that's when we had this idea of why not put a robot in students' hands, and maybe we might be able to give assignments on the robot. And I think eYantra was really born then. So it's great to have Professor Kriti with us. So welcome on board. And we have another distinguished personality here in Professor Paritosh Pandya, who's recently joined us as adjunct in the computer science department after a wonderful innings at TIFR. So he was a BTech originally from MS University in Baroda, MTech from IIT Kanpur, then PhD in TIFR. And he's done some fascinating work in logic, automata, mathematics of program construction, synchronous programming, embedded systems, real-time scheduling theory and all that. I know it sounds very mathematical, but he's one of the few guys that I know who's not only theoretically strong, but he is very hands-on. And that shows in his engagement with eYantra. He's been a champion and he vigorously engages with us. And he's got very interesting interests outside this area in the area of computational music, where he's trying to teach music to his computer. He's also built a tabla synthesizer, and he's looking at music from the computational point of view, which is very interesting. Amazing career. He's been a research officer in Oxford University Computing Lab under no other than Professor C.A.R. Hoare. He's been a visiting scientist at United Nations University's International Institute of Software Technology. He was Dean of the School of Technology and CS in TIFR, and so on. I won't go into the details of that. We have Professor Leena Vachani from the Systems and Control Department here. She's done a PhD in robotic path planning, embedded systems and stuff like that. And she's come originally from IIT Madras. She's got a master's in engineering in microprocessor systems and applications. And her specialist interest is motion planning of autonomous vehicles, autonomous tasks for underwater vehicles, multi-agent patrolling, exploration, mapping, and stuff like that. And recently, you might have seen her in the news for having developed a very interesting little robot in a transparent ball with a camera inside it, which can give you a 360-degree view of your surroundings, right? Then we have Professor Purba Joshi, who's an MDes from the IDC, the Industrial Design Center in IIT Bombay. She's faculty there, and she's the expert in product design, packaging design, user-centered design, concept development, design thinking, and these kind of things. So she's very strong in all these areas of aesthetics and product prototyping. We are hoping that with her engaging with us, she'll be able to give us good ideas with which to improve our eYantra products and our eYantra themes and stuff like that. We have also Professor Satish Vitta from the Metallurgical Engineering Department of IIT Bombay. He's originally Mysore University, IIT Kanpur, then a PhD in metallurgical engineering from Cambridge University. Now, the interesting thing about guys from metallurgical engineering and civil engineering at IIT Bombay is that I've noticed they're very good at computer systems and systems administrative work, and they've also mastered using computers apart from their specialist interests. So it's particularly interesting to see what he makes of today's themes here. And we have his interests are things like nanomaterials, magnetic and electrical properties of metals, optical behavior of ultra-thin layered multi-layers and stuff like that. And apart from that, as I said, computer systems are his passion. So we'd be very interested to see what he makes of today. So with this real all-star cast, I'd like to hand the floor over to Aditya, my colleague, who will take the proceedings from here, and it should be very interesting today. Over to you, Aditya.
Thank you, sir. Good evening, everyone. We are into day 4 of our grand finale for eYantra Robotics Competition. Today, like sir has already mentioned, we have Nirikshak Bot theme, and all the best to all the participants. Over to the theme developers, Amit, Abhinav, Kalin, Andrea, and Abhijit.
Yeah, welcome everyone. So today, this Nirikshak Bot team, we are having 5 finalist teams, and one thing just we want to mention about this finalist teams that we had a mixture of the teams like teams with experience in our previous eYRC editions, as well as those who are freshers, or you can say the first timers in this eYRC. But apparently, all these finalist teams are actually the ones who have participated in the eYRC for the very first time, and they are right now at the finals. So I think they act like this is the commendable achievement for all these teams, and maybe we should applaud to them that they have actually done their own hard work and deserved this particular place. And apart from that, just a small announcement that the order in which the teams will be called in this particular event, they will be random, and that order has nothing to actually has no relation with the score, or you can say the marks that they have.
Yeah, that's all. Avijit sir, over to you. Thank you.
So to get everyone acquainted with the theme, to the audience get acquainted with the theme, we are going to play a video now, which will briefly explain how the theme works and its components.
Namaste everyone. Welcome to day 4 of the grand finale of eYRC 2020-21. Today we are organizing the finals of Nirikshak Bot theme. Let us first look into the story behind this theme. The theme is set in an industry manufacturing ball balancing platforms. The goal is to make the balls traverse through the maze on defined paths within a stipulated amount of time in order to determine the quality of the platform manufactured. The platform, which is able to achieve this objective, is termed as OK tested. Now let us look at the learnings of this theme. Through this theme, we tried to teach robotic simulation, image processing, control systems, multiprocessing/threading, path planning, and Python Lua programming to all the participants. The technology stack used were CopiliaSim, formerly known as VREP, Python language, Lua language, and OpenCV. Now let us look at the environment of this theme. We dive into the arena first. The arena consists of 4 ball balancing platforms, T1 to T4, where teams will generate mazes on top of them. Adjacent mazes are connected to each other using conveyors B1 to B4. At the end of the mazes, there are collection boxes CB1 to CB3. This is an example of the maze image which was provided to all the participants for generating mazes on the platforms. 4 such maze images were provided, one for each platform. The digital maze image was printed and captured using a camera to specifically introduce noise in it. The JSON file consists of the color and drop location of each ball. This JSON file and 4 maze images were given to the teams as configuration files. Each platform has a vision sensor on top of it. It is used to determine the location of the ball. This is an example of a 2DOF ball balancing platform that was assembled by the participants. The ball dispenser is used to release the balls at an interval of 80 simulation seconds. The conveyor belt and the downpipe are used to transfer the ball from the center table to the adjacent tables. This is the collection box in which the balls were deposited from the corner tables. Now let us talk about the AutoGrader application. A cross-platform app helped in auto-evaluating the task at the participant's end. In the first page, teams had to enter their team ID and path of the workspace where their codes were present. In the next page, a randomized sequence of the balls was generated. This sequence, when transferred to the simulator, that is CopiliaSim, reordered the position of the balls in the ball dispenser. At the end of the theme run, the value of various parameters were listed for the teams and an encoded text file, gibberish to the participants, was generated, which was submitted on the portal. Here is our theme film. Let us look at the scoring formula now. The final score is a combination of scorer score and the judges score. In scorer score, various factors such as maze generation, correct pass, traversal, identification of ball color and drop location, correct drop, time bonus, and hit penalty of the ball were taken into consideration. Teams have performed their theme run based on given configuration, and the AutoGrader app was used to determine the scorer score. For the pre-finals, teams were given only 90 minutes to record and send the run. These runs will be demonstrated today. Judges will score teams for Viva based on ball balancing platform design, the algorithm, strategy implemented for ball traversal, control logic, image processing, and accuracy. This theme was designed by Abhinav Sarkar, Andrea Furtado, Kalin Karya, Avijit Pandey, and myself Amit Kumar. We thank Ministry of Education, formerly known as MHRD, for their continued support. We would like to take this opportunity to thank Ms. Kamadi Sahasrabuddhe, Ms. Riddhi Chaukhawala, and Mr. Anuj Chaudhary for designing artworks, teaser, and theme film. Finally, we would like to extend our sincere gratitude to Kavi sir, Rutuja ma'am, Sachin sir, Aditya sir, web team, office team, and the entire eYantra team for their constant support. We hope you enjoy the grand finale of Nirikshak Bot theme. Namaste.
It's time for our first team today, team ID 1527. I'll play their performance video in a minute.
So while Abhijit sir is playing that, a few words about this team. So this team has only 3 members and they divided the task very effectively, which is why they are the top scorers in the leaderboard task. And something different that this team has implemented in this particular team is that they have used minimum circle enclosing algorithm, which helps them to locate the ball in the maze, even if the ball is hidden under a wall, behind the wall, I mean, because of the perspective. So let's see their demonstration. Abhijit, sorry.
Myself, Vadivel Murugesan. I'm the team leader of Nirikshak Bot 1527. We are from College of Engineering, India.
Hi everyone, I'm Girinatha, pursuing BECE in College of Engineering India. I'm a second year student.
Myself, Kasi Vishwanathan, second year student pursuing BEC at College of Engineering, India.
The team divided the work equally during the span of 6 months. When the tasks were uploaded to the eYantra portal, we started working immediately. In stage 1, we mostly split the subtask as it is to each member. Then in later tasks, we had to do it together using the means of group calling, and one person shared the screen and we collaborated our ideas together.
The toughest challenge that we face is calling the control logic function as many times as possible. We optimize as much as good and call this function every 0.1 second to get an FPS of 10, and thereby we had a better control over the ball. We changed the while loops to for loops, optimized image processing codes, and avoided using temporary copies of images.
The other challenge was to drop the ball from the conveyor belt to the maze table and avoid collision due to its momentum. We elevated the angle of the top plate so that 1/4 of the ball gets trapped inside for a few milliseconds, and then we release it slowly. That way the ball becomes easier to control and avoid collision at the draw.
eYantra has forced me slowly into a person who can work efficiently. We learned how to work as a team and collectively give our ideas and solutions to solve a problem. We also learned how to manage time, balancing both college activities and competition.
The unique feature of a ball balancing design is that we have used one servo on each side of the plate, and the L connector is connected at the center of each edge. Thereby, we get no vibration, and we were able to balance the ball at any part of the table. And initially, we designed the ball balancing platform using 2 servos, but we weren't able to control the ball at extreme locations on the top plate. Therefore, we used 4 servos and we were able to achieve better stability. We have used revolute joints at places where we need one DOF, that is at the yokes, as you can see, and force sensor at places where we need rigid links. The ball balancing platform is controlled with the help of revolute joints attached to the servo fin. The handle of the revolute joint are initialized in task 3 init setup function, and then with the help of PID control, the revolute joint angles are changed in the control logic function, thereby controlling the maze.
This is the grader application. We first enter our team ID followed by the directory of the Python files. Next, we click on the start button on the GUI app. We have designed our ball balancing platform using 4 servos, one on each side. Using 4 servos provides an additional advantage to control the ball at any point on the table. The L connector is connected at the center of each edge, thus providing stability and avoiding vibrations. To maintain a real-time factor of 1 because we inverted model properties of the inactive maze tables, so that only the maze table in which the ball is traversing is dynamic in nature. We have called the control logic which controls the servo movements of the table every 100 milliseconds. The ball balancing platform is controlled with the help of revolute joints attached to the servo fin. The handles of the revolute joint are initialized in task 3 init setup Python file, and then with the help of PID control, the revolute joint angles are changed in the Python control logic function, thereby controlling the top plate. We have used breadth first search algorithm to find the shortest path to the exit point. This algorithm basically starts exploring one cell starting from the start coordinate and then expands in all possible directions until it finds the end coordinate. Hence, large number of cells can be analyzed in shortest time and the shortest path can also be found out. It looks for all possible paths unlike DFS algorithm, and this finally returns the shortest path possible. System detects a consecutive set of points in a straight path. The system skips the intermediate set points and directly goes to the turning point. We did this to traverse the maze smoothly and fastly, thereby avoiding unnecessary reduction in speed of the ball. And one interesting aspect is that based on the length of the path, we have used different PID values and different error ranges to turn, so that the ball doesn't come to complete stop during the turns. When the ball is dropped from the conveyor belt, the maze table positions itself in a way that less than 1/4 of the ball is trapped inside the down pipe for less than a second to reduce the kinetic energy of the ball, and then it releases slowly. Once the maze was made renderable, we had two issues. One was that the ball was at times half hidden due to the walls, because of which the centroid of the ball was detected inaccurately. So we used a function minimum enclosing circle, which finds the circumcircle of an object. It is basically a circle which completely covers the object with a minimum area. Secondly, we had to use a different algorithm for perspective transform. We first found out the contours of the maze image and appended the coordinates of the bounding rectangle of these contours in a list. Then we filtered out the 4 corner points of the maze by manipulating this list. Then, in order to get corners of the white part of the table alone, we considered the corner of the maze walls, and then from there search the nearest white pixel and then stored this in a list and used it as the corners for perspective transform. This is done to capture the top plate excluding the outermost walls, because if the outermost walls is also considered, then there will be deviation path traveled from the original path. Initially, during the traversal of first and second ball, there was no collision and only 2 collisions with the third ball when the ball was dropped from the conveyor belt. But during the traversal of 4th and 5th ball, as Python code runs in a single core at high clock frequency for more than 5 minutes, it started thermal throttling and there were delays in calculation. In order to mitigate the thermal throttling, we had implemented multiprocessing so that each table would run on a separate and established separate input-output port index, for each, enabling it for parallel communication as well. But this code didn't work when the GUI app was used due to unknown reasons. It threw an error when the multiprocessing line of codes began. But it worked well in IDE like PyCharm. So we had to use task 6 code itself due to time limitations. But that code was designed for shorter runtime without parallel processing.
So that was team ID 1527. Judges can start the Viva now. I request team members from this team to unmute their video and respond to the queries.
Lena, would you like to be the opening batsperson?
Okay, I was too quick in switching on my video. Thank you. Sure. All right. Congratulations, Team Anna University. Wonderful presentation. My question is more from the systems and control perspective, and of course, a little bit on the path planning part. Let me start with path planning. You use breadth first search. There are other path planning algorithms like A-star or Wavefront Planner. Are you aware about that?
Yes, ma'am. We are aware about that.
So with respect to that, why did you choose breadth first? Of course, you said about BFS versus DFS. Why not? Why didn't you choose A-star?
Yeah. So actually, there were multiple algorithms for path planning. Like you said, there are like BFS, DFS, Dijkstra, and then A star. So what we planned is, okay, initially we started exploring each algorithm one by one. So basically, I started with BFS and DFS, and then I found out that DFS always does not return the shortest path. It returns the it finds a solution, but that might not be the shortest path. So I started to code for BFS algorithm, and I implemented that in Python, and it passed all the test images. So and it also returned the shortest path as well. So since BFS worked perfectly, I need not go for a better algorithm, and it also found out the path in the shortest time as well. So I didn't explore for other algorithms.
Okay, sounds good to me. At the same time, this path planning algorithm is finding the path before even you execute the program, actual run, right? So this is already frozen the shortest path, and then you start executing it. Am I right?
Yeah, sure.
All right. So now, for example, right now it went so well. I mean, it was kind of a perfect run, what path you have chosen, and the ball was moving exactly at that place. It was not making any offshoot going away from the planned path.
Yeah.
And why is that such an ideal outcome came up? Of course, it's possible in simulations. So you had
I'd like
certain
to
noise
answer this
parameters you
question.
mentioned, right?
Yes, ma'am. What we used is PD system actually. Initially, during the task 3 in the test cases, we had used the integral term as well. But that is used only when we constantly get a steady state error. So in the later tasks, we executed the whole thing in a way that there is no steady state error. So that we used only the proportional and derivative term.
Okay.
We were able to reduce the rise time, and the settling time was also very low. Therefore, we are getting a good run.
Okay. So if I understand it clearly, the integral term uses integral control is used for making the steady state to go to 0. PD, the derivative term is to increase the rise time. But you mentioned that the steady state error is 0.
Yes, ma'am.
Without the integral term itself. Is that right?
No.
Yes. So steady state is anyways coming out as 0 through your experiments. So that's why integral term is not needed. That's why your claim is.
Actually, the reason for that is initially why we got the steady state error and later we did not get is we did changes in getting the PID output and then mapping it properly for the servo movement. So steady state error is possible when there is a very small error and the proportional term is not able to detect it. So the servo actuation angle will be very small. So what we did is we mapped it to a higher value and then again mapped it again to 0 to 90 degree, so that even for very small errors we'll get output from servo, but for very large it will be only mapped to 90 degree. So we were able to avoid this problem.
Sure. So this is okay for simulation sake, but in practice it might not be such an ideal condition is may not be possible. That's my comment. My last, in the interest of time, I'll ask only one question now. When you have designed the table, okay, so table has hinges connected at the center of the square table. Why didn't you choose the corners? Are you getting my question? You
Yes,
had
ma'am.
a table which is either moving left, right, or this way. Am I right?
Yes, ma'am.
So you, if this is the table, you connected at the center of the sides, this hinge, right? As compared to that, if I connect these four motors or the hinges that you have connected to the corners, what benefits or limitations do you see out of it?
Ma'am, actually, we tried with two servos at first, and then we moved to four servos. When we were trying to use the close to the corner one, the torque was not applied properly to the table. Maybe towards the other opposite end, when it's not when the ball is not actually close to the L connector, we can see that the actuation is not actually proper and we didn't get the best output. So we when we tested with it with the centers, we were able to control it better.
And any intuition why is it better?
Possibly because of the what I'm saying is the torque could be the reason.
Torque at the same time you made the movements independent of each other in some sense.
The motors which are positioned opposite to each other at the like in the opposite sides will have negative of that angle. So the same PID output will be used, and we are using a negative of that angle, so that when this goes up, that simultaneously it will tilt properly.
Yes, right. Wonderful, great. I'm fine, Prosarya.
Thank you. Anybody else? Satish has his mic on.
Yes, I did have my mic on. I think I'll speak if he wants to. Paritosh?
Okay.
Yes, Satish, please go on.
Yeah. Okay. So I'll ask a few very, very general questions, and I won't really bog you down with control aspects of that because I don't understand much of it. So my question to you is, will the weight of the table change, effective weight of the table, if you connect the motors to the edges and not to the centers of the sides? When you tilt, you said you were not getting a very good response when you connected the motors to the edges, correct? Corners, rather.
Yes, sir.
So why was that?
Sir, as we move away from the like from the that center point, and if we consider this case, if the motor is placed on one corner and the other side would be also close to one corner, that means like if there are four edges, and if I'm you choosing the corner, one will be close to here, one will be close to here, they're very very close by, and we won't be able to control that XY direction independently. That will affect. That's why we choose this. It will get more complicated.
Are you sure about it? Because the effective distances will be same in all the cases, corner to corner, right?
Yes, sir.
So why do you think it will still affect?
Based on our observations, sir, mainly in the simulation, this worked better, so we went with that. But maybe in a practical case, we would experiment more.
Okay. Okay. And now another question: does the sphericity of the ball make a difference to it?
Pardon, sir, velocity.
No. Spherical nature of the ball.
Okay.
Okay, so you can have still the same effective mass, but the diameters can be slightly varied in different directions. Then your control will become very different.
Yes, sir. Because we have tuned it for a particular diameter of ball with we have given a moment of inertia and a weight. So for that we have done the tuning based on the path lengths. If it changes and if the shape of the ball changes a little bit also, the way the ball moves and other things we have to consider in that case. So many other factors.
Okay. Okay. So Paritosh, you want to take on?
Sure. I can ask a couple of questions. So I think the most intriguing part of your design to me is that you said you had to change the constants of the PID controller based on what you call path length. Now, what do you mean by path length? Where is the what is the frame of reference? Where is the origin, and how do you this parameters depend on what? Absolute distance from it, or the some measure of x coordinate difference, y coordinate difference? What did you do? Can you give some details?
Okay. Yes, sir. Sure, sir. So initially, when we find the path, we get uh, a list. We get a list which contains the set points. That
Right.
means this set point will be in each wall length. This will be like maybe I think 10 centimeter length.
Mhm.
But if the whole turning point, if they are in a different length, as in like if it's a consecutive of more than one wall, like 10 centimeter, 10 centimeter, 10 centimeter. In usual case, what it will do is it will stop and go because more set points will be there. For the system,
Okay.
it will seem like a set point. But then we know that we don't have to stop the ball in between. We want to slow down the ball only when we need to change the direction of the ball. So what we did is we selected if the path consists of more than like 40 centimeter, then we are skipping the in between set points and directly going to the turning point.
I see. No, that I understand, and I
Okay.
think that is a good idea. But my question was more about when you program the PID controller, how did you tune the constants of the proportionality constant or the derivative constant or you didn't use integral. So the P constant and the D constant, how did you arrive at that value?
Okay, sir. So, what we considered as a proper set point in the list is where there is an immediate turn. Like the ball will start moving, and after just a 10 centimeter, it has to turn. For
Yeah.
that, we stored all such set points in a list, and we
Right.
named the list. And for that set point, we tuned the PD values. Then for
How do you
the
tune
set
it?
points,
How do you tune the
Through
values?
trial
What
and error, sir.
method?
By trial and
so
error.
trial and error, sir.
Can you describe that in a little more detail? And do you know there are any principles that you can use in tuning the PD controllers?
So we tried to use the other methods which were available in the internet, but initially what we went is with first we gave a value to the proportional, then we saw the graph. There will be a graph in that, and based on what we see on the graph, we increase the d value according to the overshoot, because the proportional control, just while using that value we got to overshoot. So in order to reduce the overshoot, we started increasing the d value. That's how we tuned it.
And how much do you reduce it by? If you saw an overshoot of a certain amount, how much do you reduce it by? You had any, when you could reduce
We
it
do not have
little
much
or very
overshoot.
little? It was trial and error, is it?
Yes, sir. Because this was a 2 degree of freedom system, we couldn't actually use a proper technique until we get the transfer function of it. the whole
Right.
system.
Okay, that's excellent. So now you come to transfer function of such a system. Do you think this system is linear or non-linear? The actual real transfer function from physics point of view.
Sir, actually, we did not focus much on that part because the instructors told us you can use any method or trial and error. So
Okay,
we don't, yeah. So when we used the trial and error, it worked. So that we didn't want to waste much of time because of the deadlines.
Right.
But then we did go through the methods and tried it, but it did not work very well for the system.
Okay. Yeah. I think I have one last question. You know, you've experimented with this ball balancing table. Huh? What could be be some possible applications of such a table? Where do you think it would be useful?
Sir, I think it will be used in the manufacturing of any object which is spherical in shape, so
In
that
what way?
from one, sir,
So
like after the manufacturing of that object, the we use conveyor belt basically in industries to move the objects from one set of one section to another section. But if we want to sort it, we'll use more conveyor belts in that case.
Yeah.
So instead of using
Carry
that,
on.
using this image sensor setup and these type of tables,
Mhm.
we can reduce the number of conveyor belts. That is one use that we saw.
Okay, so you are thinking of this as a kind of, flexible platform, a kind of system to move objects around in tree or somewhere, is it? So you can move or something like that.
Yes, sir.
Okay,
Kasi or
fine.
Giri, would you like to add some points to it?
Yeah.
Yes, sir. There is another. We can also use it in another application like we can still code a little more. Like the PID tunings can be based on the mass also. And if there is a ball manufacturer who manufactures balls of different kind of masses, and by knowing the mass of the ball, we can separate it into uh, different platforms where manually picking up balls and storing it in different containers where it needs to be exported. The ball balancing platform can be done once if we do the PID controlling on basis of the weight of the balls, and provided that we know the weight of the balls before the ball is entering the maze. There are many methods for us, like force sensor we can use, or we can just let the coding part also a little bit modifications.
Okay.
Okay, should we
Yeah,
move on?
I'm done.
So
Can I just had a small question to ask?
yes, please.
Yeah, so the mage table is a square. It's a perfect world. But what if it is a circle? Because as a child, I have played with this kind of a mage wherein it was a circular box wherein we had to take these steel balls out from one part to another part.
Right.
Yes, sir.
So how, sir, are you asking how would we implement this in case of a circular table?
Where do you put the motors in that particular case, because you don't have any corners or edges?
I think for circular, 3 motors would be sufficient, and by tinkering we would have found the precise number of motors which would be required. And but where we would concentrate is that we would place the motors exactly opposite to each other, sir, to have an effective and control on the ball that is traversing on the top plate.
We can also use. Like we have to divide the entire circle into 3 equal parts and place the motor at the close to the edge of it, or a little bit inside itself. That would be fine. But just the tuning would change according to it. But the important thing is the motor should be placed with equal distance.
But you could have done this also with a square board, right? By having a round rim inside it, where you can hinge it with 3 motors, no?
Yes, sir.
So, Satish, thanks for that. I think the questions have been really interesting, but I'd like to highlight to these guys that, if you just think out of the box, what you've learned actually is how to design and tune control systems to achieve a goal, right? Think of this board that you're trying to balance as maybe you could put a big chair on it, and you can build a flight or a vehicle simulator where you can get the wheel information or terrain information and keep on moving this thing around to kind of simulate the terrain of an area that the vehicle is meant to be going over, right? That's a possibility of what you can do. You can build a flight simulator with this. You can build a gaming platform with this. In fact, I've often fantasized about building a suspension inside a rickshaw. You know how a rickshaw is very uncomfortable? So if you could have a suspended kind of platform, a seat inside, which has servo motors or linear motors at the edges, and you can compensate for all the bumps on the road and give a nice ride. There are lots of things that you can do with this. So what you really learned is control systems, right? And you can apply these things to anything that you want. So it's not only balls on a platform and things like that, moving around, quality control and all that. That's just one particular application. But I think you've learned some very important things here. But nice job and a big hand to you guys because you've come up with some good ideas in your implementation. And big hand. We'll move on, right? Because we have limited time and we shall keep it to about 15 minutes a team. Thank you guys. And over to you, Aditya. Is it Amit?
Andrea sir actually. So I request all the judges to award the score to team 1527. And the next team is team 64 from College of Engineering.
Yes,
I didn't
Kriti.
ask my question.
You can still ask.
Yes, yes.
Okay, I
Team
have only one question to be asked. Okay, and that is a real table will have a friction in it, right? What did you make assumptions about friction in your design, and what happens if those assumptions don't hold?
According to our question given, the top plate is frictionless, and if there is some friction to the top plate, there will be definitely some changes in PID tuning, sir. And other things that will not be a necessary change. Only PID tunings need to be changed.
What changes will you make if there's PID?
The P and D constants we should have varied, and that will also we would have tried through trial and error method, sir.
So
I would like to add a point.
Yeah.
If we add friction to it, that means there will be resistance to the motion of the ball. So here in this case, we took frictionless, so there is no resistance towards the motion of the ball unless the table moves itself. So on a on a table where there is friction, there will be some resistance to the ball movement. So according to that, the proportional will increase because we have to move a little bit more. There is more resistance, so we have to give a little bit more extra force for the movement.
Okay. Well, what are the other techniques from computer science that you discovered may be useful in your design? Are there things that you learned which were not originally specified as required skill set, but you found that knowing them would have been helpful?
Yes, sir. The first thing, other than algorithms, what all we learned was we learned how to run the code in a very short period of time, sir. Even like there is a time for running while loop and for loop, and we instead of running an infinite while loop like while true, we change it to for loop. So such kind of things we discovered only through this competition. We were thinking that there's both while true and the for of infinite loop is same. Such small tricks from code for 0.1 second. We are calling the control logic function for 0.1 second. For 0.1 second, so that logic function should of minimum time. It should take a minimum time to run.
Okay, so Kavi, I'll stop here.
Nice question. Thanks.
There's just one correction over here that I'd like to tell CP sir that the table was not frictionless actually. It was with friction. There was a defined friction already in the physics engine, but yeah. Anyways, I think we should, in the interest of time, we should move on to the next team. So yes,
Thanks,
Andrea
guys.
ma'am,
Good
over to
luck.
you, please.
Yeah. Kirti sir, do you have a question?
No, I'm done. I can.
Yeah. Okay, so the next team is Team 64 from College of Engineering, Trivandrum. And this team had very well anticipated the upcoming task and had a pre-planned their strategy. So, which makes them the first team to use the multi-threading approach. Another thing about this team is they had a very low RTF of about 0.35, but they had a robust algorithm. And how they made their algorithm robust is by testing their code against all possible test cases that we had provided, and also they created a set of their own. So let's check out their robustness of algorithm in their demonstration. Abjit sir, can you please play the video?
Hi, I am Sumaya AK. I'm a fourth year EC student from College of Engineering, Trivandrum.
Hi, I am Prasida S, fourth year EC student from College of Engineering, Trivandrum.
Hi, I'm Shyama. I'm a fourth year Electronics and Communication Engineering student from College of Engineering, Trivandrum.
Hi, I'm Srishma.
Hello,
I'm a
Abhijit
fourth
sir,
year
are you
Electronics
there?
and Communication Engineering student from College of Engineering, Trivandrum.
We divided our task in such a way that each member was assigned to a specific domain. Shyama and Srishma worked in image processing, Prasida was mainly doing 3D designing and the Lua part, and I was in charge of control system. Apart from that, we divided our task into algorithm building and debugging. Thus, all the members were able to work in different aspects of the project.
The first hurdle was working together as a team in the current scenario, but now that we are here, I think it's safe to say that we have dealt with it efficiently. Regarding the task, the first challenge was image processing because we were all beginners in it, and it was our first time designing a control system. So the designing and tuning of our PID controller was a bit overwhelming. eYNTRA was not just a competition for us. In the past few months, we really enjoyed working on each task, as each one of them was an opportunity to think, understand, and practice. This was a platform for us in many ways. We learned to work as a team, we learned time management, and eYNTRA helped us improve our problem-solving skills.
Our team was assigned the task of designing a 2DOF board balancing platform as part of the theme. The unique feature of our board balancing platform is that we aimed at achieving the best performance using the minimum number of resources or equipments. So we have achieved 2 degrees of motion by using 2 servos. We have used a universal joint at the center of the model which supports 2 DOF motion. Initially we considered the use of 2 as well as 4 servos, but in our simulation we found that the universal joint was capable of holding the weight of the top plate. Also, in the case of 4 servos, the 2 servos which would act on opposite sides would perform the same job. Also, reducing the number of servos which would reduce processing. Thus, we have finalized our design by using 2 servos. The servo fin is connected to the servo by using a revolute joint which is motor enabled. The servo fin is made to rotate in the range of -90 to +90 degree. This rotation of servo fin causes the up and down motion of connecting rod which is connected to servo fin by using a revolute joint. This up and down motion of the connecting rod causes tilting of the top plate which is connected to the connecting rod via an L connector and a spherical joint. The spherical joint being a 3DOF joint assures smooth movement. The platform is controlled by using a PID controller which computes the error in ball position. This error is used to adjust the angle of the servo fin accordingly.
Simulation starts with the generation of mazes on top of the tables. The provided maze images are processed to form encoded maze arrays which are used to generate walls on the tables. The first ball is dispensed from the ball dispenser and is transferred to the first table T4 through the conveyor belt B4. From the conveyor belt, the vision sensor 5 detects the ball and the color of the ball is detected. Here it is red. The collection box is determined by reading the ball details JSON file provided to us. Here the collection box is found to be CB3 on table 1. The path drawn on top of maze is found using A-star algorithm. We used A-star as it gives the optimal solution by using heuristic function in a shorter time. The second ball has dispensed from the ball dispenser. By this time, The first ball has completed its traversal. The second ball is a blue ball and its collection box is determined as CB1 on table 2. It is transferred to the table T4 for traversal. The ball motion is controlled by the PID controller. From each table, the corresponding vision sensor image is processed using image processing to find the ball coordinates. The error function used by PID is responsible for the movement of the ball. For the traversal of the ball, set points are adjusted by the traverse function. We haven't taken all the cells in the path as set points. Here the cells on which the ball has to turn are taken as the set points. Now the third ball has dispensed. It is again a blue ball and its collection box is determined as CB3 on table 3. Sometimes there is a need to control two tables simultaneously, as seen now. So we have used multi-threading where each ball is controlled by a different thread. The ball detection at vision sensor 5 is done by the main thread. Also, before dropping each ball from T4 to the next table, our algorithm checks if the next table is free for traversal or not. If table is occupied by previous ball, the ball waits on the last cell of T4. We improved RTF by deactivating all the tables initially and activating only the required table. For example, in this case of third ball, T3 is activated before starting its thread. We also made sure that we closed the dead threads after every ball is traversed. The third ball has almost completed its traversal, while the fourth ball has dispensed from the ball dispenser. It is a red ball and its collection box is determined as CB1 on table 1. Here when the fourth ball is detected, the algorithm finds that threads corresponding to ball 2 and 3 are dead but yet to be joined. These are joined with main threads and the tables used by those balls are deactivated before starting the thread of ball 4. These techniques helped us to optimize performance by maintaining the desired RTF. Another challenge we faced was the detection of ball on the top of table when the mazes were enterable. To overcome this, we modified scan image function to get the desired output. Even though the fifth ball has dispensed, the fourth ball is still on the table 1. It hasn't reached the collection box yet. Now we can see the parallel processing. Both the fifth and fourth balls are traversing at the same time on different tables. The last ball is a green ball and its collection box is determined as CB2 on table 3. Another challenge was finding the ball coordinates when the ball passes through the end cells as seen now. The height of walls was making it difficult. We used half circle to estimate the circle and to find the centroid in this case, and minimum enclosing circle when half circle was not giving the proper results. Tuning the PID was the most difficult part for us. We found that ball underwent collisions on traversing long paths. To solve this, we considered increasing set points when the difference between two set points is large. With all this, we could come up with an algorithm that gave us good results. Thank you.
So that was team ID 64. I request all team members to unmute their video and be ready for Viva from the judges. Judges, please go ahead.
Lina is our opening batsperson.
I switch on my video faster than anyone else, I think. Anyways.
Good job.
Yeah, okay. So thank you. First of all, congratulations, team. I see all girls team this time. Thank you. Thank you, girls. All right. So girls, I see my question here is more towards the control system mechanism. And you have feedback from vision, right? Why do you need that vision feedback when things are all working in simulation and perfect ways? You were taking feedback from the vision, right?
Yes, ma'am. So our communication with the Coppelia sim works through these maze images. So we had the vision sensor images feedback and to take the coordinates of the ball. So that's why we were using that feedback.
At the same time, you use
When
multi-threading, and there is some concept about in control system about the control bandwidth. Are you aware about this or the loop time? No, no
Sorry,
idea.
ma'am, I didn't get you.
So basically, the feedback vision algorithm must be taking some time to calculate the position of the ball. Am I right? Because your claims are more.
Yes, ma'am. The image processing takes some time.
Yeah, image processing takes its time. Then it must be passing on to its information to the control loop. Is that right? So this vision system,
Yes,
did you try to minimize its time? Because that's coming out in the RTF calculations, claims that you have made.
Yes, ma'am. We had a sample time. So we weren't computing all the images that we were getting from the Coppelia sim. We had a sample time. We only took samples once in 3 images. We only took one image from the 3 images we got. So thereby we tried to reduce the computation further. So that was one of the thing we did. But when we increased the sample further, some inaccuracies were occurring. We had low RTF, so we had to maintain it to at least to 1 in 3. So that was one of the things we used.
In between, when you had increased the sample time in some way, basically feedback, so that you are able to calculate the feedback on time in some way. So what was your the control, if I want to say it in a very simple way, when you are giving the trigger to the control, okay, what time intervals were you giving?
We were giving it a 0.15 second.
0.15 seconds. And so out of that 0.15 second, have you tried to see what is the video processing time? It was exactly 0.15 or it is more?
Actually, the real-time factor was varying. The things that were going on our system were slow, but we tried with different sample times, like 0.1, 0.05, 0.2. So for less sample times, the system were accurate, but the real time was reducing. So I think the video processing was more when we took more samples.
Okay, so when video processing is taking larger than 0.15 seconds, so what is the feedback value that you are giving to the control? That's my exact question now. Are you getting
feedback value?
Are you getting my question now? You are giving triggers to the control loop at every 0.15 seconds, whereas your
Yes,
video
ma'am.
processing or the feedback is coming after 0.15 second, or
yes, ma'am,
it's taking more time, right? So
No,
when you are it's lesser than 0.15 seconds.
Actually,
It is varying. Is it lesser than 0.15 or it is more than 0.15?
Okay. Actually, the images are coming as a buffer, like it's streaming from the Coppelia sim. So, we are giving the trigger to the servos at every 0.15 second. We were using the simulation second, the real time was not constant, but the simulation time was constant. So, at every 0.15 simulation second, we were giving the trigger to the servo motors. So, it was constant. But sometime when we're when in multi-threading and the sample time were varying to some 0.05 second. That was due to two balls controlling at the same time, two tables controlling at the same time. So there was that issue sometime, but most of the time it was a constant.
Okay, I got partial answer, but that's okay. Let me move on to next question.
Can I just add on to that?
Yes, please. Yes, Prasida.
Actually, the video processing time was less than 0.15 second, and we were getting more than within 0.15 second. We were getting sometimes we were getting 2 images, sometimes we were getting 3 images, and so on.
I
So
see.
in order to make it uniform, in order to make the time interval in which we control the table uniform, we provide the concept of sample time. Otherwise, if we are directly taking the time that it takes for processing to control, then it will be happening at different intervals. So we have put a uniform measure and use the concept of sample time.
Okay, wonderful, wonderful. All right, good. Now the next question here is, you have to endorse if my observation was correct. Sometimes the ball is moving faster and sometimes slower. Is that right?
Actually, for like very small distances, the derivative part was like a bit higher, and so it was moving slower. And for the longer pass, it was moving faster. Like we took only set points at the turns. That's why.
I see. I see. So your derivative terms are more or less related to the path length. Is that right?
No, because like we had initial collisions, so to reduce that, we like kept the derivative part a little higher in order to avoid that. But due to our RTF, we were still getting that initial collisions. But due to that derivative part, a little higher derivative part, in small path lengths, we were getting a slower movement, and for long paths, we were getting.
What is the effect of derivative? Does it increase rise time or reduces the rise time?
Okay, the rise. It will reduce the rise time. Like.
Okay. So can you relate your answer to that?
Like for the when we increase the proportional term, like proportional term is mainly for this increase in rise time and like for improving the speed. To get a control in that speed, to get a control in that rise time, we are using this derivative part. So like so that's happening there, I guess.
Okay, okay. So basically, if I give you the answer, what I got it, since your path length is small, your rise time is small because you have increased the derivative term, and so that is why it slows down in some way, because that's where the change is happening to the path, and perhaps that's why it was working. That's it. Okay, so you can relate it later to my answer and think carefully. Thank
Sounds
you.
like an MTech, sounds like an MTech interview.
Sorry.
Sounds like an MTech interview. Is it? Okay. Paritosh.
Yes.
Paritosh, a question brewing. I wonder if Purba or anybody else have anything to add to that. But Paritosh, since we can see a question brewing on your face.
One quick question then. So you see, what is the when you do path planning, what kind of path you are finding using eYRC?
Okay, I will pass that question to Shreshma.
Yeah.
Yes, sure. We are finding the shortest path, sir.
Okay, good. And is eYRC guaranteed to find the shortest path, optimally shortest path, or will it find a suboptimal?
Actually, we were getting the shortest path all the time.
But do you know theoretically this guarantee is there in the algorithm?
Actually, we compared different algorithms, and we finally, with all the things like the shortest path, the shortest time, and everything, and we found that eYRC gives the shortest path in a shorter time compared to other algorithms. So that's why we chose eYRC.
Okay, and it always gives shortest path.
So
Yes,
may
sir.
I add a point?
Yeah, so
Yeah.
from what I understood, A-star always guarantees the shortest path, but there is a condition that A-star depends on the heuristic cost. So the heuristic actually we are taking is not the exact distance between the current and the target cell. It's like an approximation. We are using either Manhattan or Euclidean or some kind of a distance like that. So for different, I
And
think
is it an admissible heuristic, the one that you are using?
um,
I'm
yeah.
partly solving it for you.
Yes, so we actually we had only 4 directions of movements. Like we didn't have like either up, down, or left, right. So due to that, we actually chose Manhattan distance to be the heuristic.
Which is fair in maze. Yeah. Okay.
Yeah.
Fine. I think that is enough for the moment. Might be worthwhile studying the theoretical properties of these different search algorithms, with respect to optimality. But my question is that why do you concentrate so much on shortest path? Your objective is to finish in shortest time. So suppose you were given very high marks for the amount of time, amount of less time that you take in finishing your traversal. Okay. Then do you think shortest path is the best measure to use, or should you be concentrating on something else?
Sir, actually, the path for the maze, we are finding it initially.
I know,
So
but it's a planning problem, no? You are planning that path.
yeah, yes, sir. So actually, A-star will give the solution in less time also. Comparing to
That I
this
agree.
other.
Perhaps my question is not clear. Suppose your algorithm is giving the shortest path. We accept that. Huh? Now, is that the best path going from source to destination in shortest time? That is my question.
Yes, sir. The distance is always proportional to B into T. So everything will be if we get at shortest distance, the time will be less.
So I from my house to IIT, there are 2 paths. One is shorter, but with lots of turns, and another one is just go straight to the highway, and then I move along the highway. What do you think will reach me to IIT faster?
But sir, in that case, that there are less chance, but we can take that chance. In some mazes,
you can explore many paths and see which one has more turns or not.
Think about it.
Okay. So shortest time is very different from shortest path. You can also increase the velocity of the ball so that it moves at twice the speed. Now, how do you decide at what velocity you are going to move? How much you are going to tilt the table? So there are many aspects to this problem.
Good, Paritosh.
Yeah, thank you.
We've been edified. Wait, Kriti, you had a question?
Yeah, I have a question. So suppose you could modify one aspect of a design in what you had. What would it be? To get better results or better designs or more interesting principled approaches to making a solution happen, things like that. So what would you change?
okay, the major challenge we faced were the initial collisions. Out of all the collisions we got, the major collisions from the initial part. So we will try to reduce that design part, adding some more control technique, algorithm change in that part to reduce collision.
Maybe others? Any other possibility? Is everything else okay?
Yes,
Perfect. Is everything else okay as is? Don't you want to change something about what exists in your design or in your implementation? Would you modify something in your approach to the solution?
Okay, I think Prasida can answer about that design part.
Let me put it this way. Were there any nights you could sleep because you wanted to make the design change and the others did not agree? Now we have a chance to make it.
So about the design part, initially we had designed it with 2 as well as 4 servos. But while I was assembling the parts and running the simulation, what I observed was that the the middle piece or the universal joint which was used in the center was itself capable of holding the weight of the top plate. Even if we didn't use any of the servos or L connectors at the sides, even if we were not holding the top plate from the sides, it was stable on the universal joint. So we just had to tilt the top plate according to the two axes, X and Y axis, and therefore we came up with the design of two servos. And moreover, we also had to concentrate on the processing part, and using more servos will lead us to doing more of processing in order to control all the servos. So we concluded with two servos in our design.
Okay, so I'll stop here.
Okay. In the interest of time, do permit me to move it on. Interesting, girls. But I was just thinking that if you had to change things, what would you change in this, right? So do think about it, because the jury has asked you this question because they can think of better ways of having achieved the end. Now your homework is to think of what that better way might have been, because we know that there's a better way. Okay. So just think about that. And a lovely effort. And it's great to see an all-girls team, right? Big hand to you guys.
All the men's team.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
All the best.
Yes, and we'll hand over to our lady now, Andrea.
Thank you, sir. So good job, girls. Next team we have is team 497 from National Institute of Technology. But before I mention a few words about them, I'll request all the judges to please award their score to team 60. So this team consists of four first and second year students, and all of them belong to a different department. That is, there are two from chemical department, one from physics department, and one from electrical department. And in spite of not meeting each other, like in physically, they have collaborated really well and reached this particular stage. And the strategy that they applied is that they devoted a fixed amount of time every day for the competition. So that's how they balanced the competition and their academics. And something different that this team has thought about is that they have a different approach of ball traversal. So let's see this approach in the demonstration.
Hi, our team was Nirikshak Bot. Our team ID is 497. We are from National Institute of Technology, Calicut. Myself, Abel, leader of the team.
My name is M.K. Atishan.
I am Ajinkya.
I'm John Johnson V.
I work mainly on designing the ball balancing platform, also testing and validating the final code.
My area of focus was to develop the ball tracking algorithm, path planning, communication between the copy sim and remote API, refining the control, and developing the final team run algorithm.
My major contribution was in the role of testing and simulating, particularly with the part of PID.
And my major contributions were mostly in PID design, mesh decoding and generation, the ball traversal, and the final theme run implementation.
We started off with a very basic PID that had its fundamentals rooted in the Ziegler-Nicholas method. But that proved to be a bit time-taking and inaccurate. There were a lot of instances where it overshoot and it lacked a grasp for control assumptions. So we had to modify the skeleton, and there were constant updations and amendments made to reach the final one that we have now. So this going off the basics is absolutely challenging.
One of the major challenges that we overcame was trying to control two balls simultaneously at different platforms. We initially went with multiprocessing, but since this turned out to be too complex and time consuming, we switched to concurrent programming.
One of the biggest learning experience that we had is how to be more patient and not to give up at something.
The positioning of the servos at the adjacent sites along with the support which is provided at the center is enough to make a simple ball balancing platform. And we got this idea from a YouTube video named Acro Ball Balancing Table.
The algorithm sends signals to each fin that tell them to rotate in a certain way. The connections from each fin all the way up to the top plate ensures that the platform inclines in the way it's intended to. The servo fins have opposite orientations to each other. This was done to make the code structure more aesthetically pleasing. Our code is generic enough to support each and every table, the only changes being the table serial numbers like T1 and T2.
In order to make the support at the center, we use two yokes along with a universal joint. that were connected by using two Revolut joints. We have two servo motors, so it requires four servo holders to holding the servo, and each two servo holder for each motor. The shaft of the servo motor is connected with the servo fin. The servo fin is then attached with the connecting rod. The other end of the connecting rod is connected with the L connector. The L connector and the connecting rod are joined by spherical joint, and the joint between the servo motor and the servo fin and the connecting rod and the servo fin is Revolut. So such a similar connection is made to the other servo also. So thus we completed our ball balancing platform. Thus in total we have used two servo motors, four servo holders, two connecting rod, two servo fins, two L connector, a base plate, a top plate, two yoke, and a universal joint.
So we are about to start our evaluation for the final theme run. Now the grader application takes control over the simulation. We can see that all the mazes have been successfully decoded and generated. Now as the simulation has started, we have the blue ball arriving first. This ball will be navigated to the collection box 1 of the table 2. All the balls travels through table 4, which is a main table. We can also see that the path to the corresponding table has also been drawn successfully. Now the ball has collided twice at the ball. One of the greatest features that we have introduced is that the ball will only slow down at the turning point if the path is very much straight. Now the first ball has been transferred to the table 2, where it will be navigated to the collection box 1. We use A* algorithm for path planning, which uses heuristic to find the shortest path, which also take care of the direction. Now we can see the second blue ball is about to arrive to the table 4. Now we can see that our first ball has collided just when the second ball arrived. This is possibly because we switched our algorithm to a concurrent process so as to support the traversal of the ball on both the tables. During this process, we decrease the differential gain slightly so as to counteract the time delay that is being occurred in order to execute both the process concurrently. Tuning the gains in order to support two balls was something that we couldn't achieve with a great accuracy. Now, the second blue ball has completed its traversal on the table 4, and now it is making its way to the collection box 3 of the table 3. Now, the third ball with red color will be navigated to the collection box 3 of table 1. Another interesting aspect that we have introduced is to provide a counteracting torque just when the ball enters a platform. This way, we were able to reduce the collision of the ball at the walls near the downpipe. We have also introduced a tilting algorithm that would incline the table to a maximum possible angle just when the ball reaches the exit point, which would help us in saving time. Now, the fourth ball, which is green in color, will be navigating to collection box 2 of table 3 via the main table.
When a ball leaves the primary table and enters a secondary table, the code simultaneously checks the vision sensor input at the initial conveyor belt for any new balls. If it detects a new ball, the code assumes a special case in which it deals with two balls in different platforms in a concurrent manner.
Now we have the last ball, which is red in color, will be navigating to the collection box 1 of table 1. Another interesting feature that we have introduced is a ball retraction mechanism. By this, we mean that Suppose if the table is subjected to some external disturbances or an faulty image frame which causes a ball to drift from its current set point, the ball retraction mechanism retracts the ball to the previous set point from where it can continue the rest of the path navigation. Now that completes our team run with a total hit penalty of 10.
So that was team ID 497. Well done. I request all the team members from this team to get ready for the Viva session. Please turn on your mics and video camera, webcam. And now I pass on the floor to the judges for questioning.
Paritosh?
Maybe.
Yeah, this time
Okay.
I request others to start. Thank you.
Yeah, a short question. I think others should ask first. But okay, so I have this question about your algorithm design. So you planned your path, and the paths, consists of line segments with turns, right?
Yes, sir.
So when you come at a turn, what does your algorithm, your PID control try to do? Is the velocity of the bot become 0 when it comes to the turn, and then it starts moving again, or do you sort of take a smooth turn at the corner and turn around? What is it that your algorithm tries to do?
Yes, sir. So our actual velocity doesn't become 0 because the ball will be having its own inertia, will be navigating to the turning point. So if the turning point, the only the PID will be taking care of the.
No. But what is the error term that you give to the? How do you measure error at a corner?
Yeah, at a corner, you mean the set point.
Yes.
Yes, actually, the error will be basically starting to measure from from where it starts. Like if the ball is starting from a particular set point, from there it will be starting the error to the corner point. So when it is about to reach the corner point, then we have set a error limit in which if the ball is within that limit, then it will be taking the set point. Then the set point will be shifted to the next set point. In that way it will be navigating, like it checks for the error and it will be navigating. I would ask Aditya to add. Would Aditya like to add some point?
Okay.
Yeah, basically whatever Abel said is the same way. We don't wait until it actually reaches the correct point of the corner. We actually have I guess, say a radius of error, and if we are talking like that. So when when that error is met, we immediately we immediately change into the next set point, and the ball then gradually goes there as planned. Sir, I think you're mute.
Okay, Kavi, can I ask a couple of questions before Paritosh comes back?
Yes, sir.
Yeah, okay, fine. So just to continue what was being asked earlier, do you choose between the shortest distance path, or you want to choose a path which has the least amount of turns?
So, sir, in the SR algorithm, actually finds the shortest distance path. So we don't have a time factor in that. So we didn't count any turning points in that algorithm. So it is not like special.
But which one would be a better option to do? You can have a straight from entry to exit. You can have a straight path wherein you don't have to change the velocity of your ball at any point and then reach the destination. But on the other hand, you can have a shortest path with many curves or turns. in which case you will have to decelerate at every corner.
Yes, exactly. One point I think is that even if the path is straight, and if there is a corner point, that is, if it is taking a corner, then it would have to traverse a 3-cell path, which means that under any some circumstances, it is very less likely that we would get a path with a turning from the ASR algorithm, because for a cell to be turned, the net traversable path is 3 cells. So for the same path, there will be only one cell that has to be traversed. So I believe that in most cases it will be especially in our maze that won't happen.
Okay, because since your group has got a physics candidate as well, let me ask you this particular question. What if the object, in this particular case, it's a spherical ball, correct? Which is being transported from one maze to another maze. What if it is a cylinder?
If it is cylinder, then we have to make sure that the ball will be landing in the correct axis of rotation. So in that we have to do something at the end of the conveyor belt itself in order to make the ball fall in that particular direction, because
No. Just a second. See that it is not a ball; it's a cylinder that you are transporting from one point to another point. So in which case, you not only have to talk about the tilt, but you also have to take care of the wobble of the cylinder if it is moving at a particular velocity.
Yes, sir. So as a cylinder alone, in the case of a maze, I believe it would be very difficult in order to make the turnings and all, because the design we have is currently only in 2 direction, and that to the cylinder for a cylinder, the velocity, the gradient of the velocity will be different in order to make the turning point. So in that way, I believe for turning point, it will be much difficult in terms of this design.
So what other controls do you need, or what other accessories will you need in that particular case?
I would like to add a solution if cylinder is the case. So the cylinder would definitely roll that in the curved portion. So one solution would be to at each corner point we would have to rotate cylinder such that it should have to roll on that exact curved part. Otherwise, it would be very hard. So, would be harder. So that is one solution, rotated corner points.
Okay, so yeah, Kavi?
Yeah, Lina, one question before we move on, in the interest of time.
Okay, sure, thank you. I have rather a question related to multi-threading this time. You have implemented multi-threading wonderfully, all right? So the threads are based on the table, the primary table and secondary tables, right? Is that right?
No, we actually don't use multi-threading. We use actually if the two processes occurs in a concurrent manner. Suppose if it is balancing table 1 first, then it will be balanced table 2 for the second time. Then it will roll back to table 1 and table 2. So that happens very fastly.
Okay, so multi-processing kind of concept, is that right? Concurrent processes are happening. Once the one process is executed, the next time it is the other process.
Yes.
Right, wonderful. Right. Okay, so at the same time, you have implemented very nice high-level decision-making parts where you mentioned that if there are certain faults from the video processing and you are not getting the feedback, then you do some kind of makeshift arrangement, right?
Yes.
That, can you elaborate quickly?
Yeah, the reason why we implemented is that if suppose a ball comes for the first time, and due to some kind of even if we are making some kind of disturbance, the ball will go to a location mainly at the corner part where the ball will be hidden in between the walls. So in that case, the vision sensor will not be able to dictate the ball. So in the so that's where our entire control logic will break, because we are not getting the centroid and it will be empty. So instead of that, what we take is that what was the previous location we have. With that, we will be trying to navigate.
Okay, wonderful. And that concept is in some way related to state estimation, let me tell you, the high level language that we use, where we use, if we are not getting the current state, then we use the previous state and predict what could be the possible state. You might not have applied the prediction because your sample rates are very high, and that's why it's working. Wonderful effort. Thank you so much.
Yes, ma'am. Thank you.
Thank you. In fact, I have a question. I think one of you guys, it was Aditya, said that you tried to do a multi-processing approach, but it became too difficult and you had to do the concurrent approach. So can you just enlighten us as to what exactly happened? Where did you get that?
Okay, sir. Yeah. So basically, we actually first tried multiprocessing, but the communication between each process, we had to communicate to know at least between the server and the process that handles the each table. We had to communicate between the server and that. But as we tried, there was some problem because we didn't get it. We didn't get the communication did not happen somehow, and we were not able to find that quickly. So we switched to concurrent programming that we had already developed on the side, and that produced results that you know bad. So we focused more on that, and we got what.
So Paritosh, I see a question brewing in your mind.
Sir, one point I would like to add is that the reason why didn't we go in the multiprocessing way is that we till the code we were also anticipated about two tables. So also there were many states that we are managed when a single goal is being traversed. So in that case, we had to go for an approach where we be sharing the memory, like the path to be traversed and the set point change. So in that case, if there are multiple tables, it would be very difficult for the memory to be shared, and it will be very difficult for the for debugging purposes also. Suppose we want to read some kind of information, then because we were using many Boolean functions extensively, so that became that were also some difficulties since as far as we have explored, we didn't find any Boolean variable that to be shared. Maybe we could do with the zeros and one, but we did.
Okay.
Yes, sir.
Paritosh, you had a question brewing in this? We can't hear you. You're muted.
Sorry, if there is time, they said
Yeah.
that they use Ziegler-Nicholas to tune the PID controllers. Did you say that?
Yes, sir. Yes, sir. Sorry, I answered that.
So, can you elaborate? There are some time constants to be inferred there, right? So, what are the steps you followed?
Yes, sir. So in the task 3, we were actually provided with a graph where we have to balance the ball to a current particular set point. So first then in the process of cycling across, we have to find the ultimate gain and the timing constant for that, which is TU. So for the finding the ultimate gain, we have to make the integral and derivative terms 0, and then we find the. So one of the we weren't actually able to make the ball in a neutral stability because we exactly don't know the reason for that, because the either the graph will show converging or diverging oscillations. So it kind of an approximation we made in the ultimate gain part, and the next step we did was there were a few sine waves that were shown in the graph. So we kind of approximated that time as our ultimate gain between the two consecutive trough points, and from there So from there we find that TU part. And another method what we used that since we weren't able to get the ultimate gain, we actually use that differential term also by setting the integral terms. So we have two part, KU, the KA part and the KD part. So with that two part, we made since the steady state error was only left, we use both of the KD and KA to make a kind of approximation from the equations that we use in the Ziegler-Nicholas to measure the integral part. So it is not exactly the Ziegler-Nicholas method we use. We kind of approximate. Yeah.
I would like to
you improvised, yeah, and approximated.
Okay, but
I would Aditya would like to.
I'm done.
Yeah. Typically, what happens is that because of the lack of time, they don't explore too many things, and the first thing that works, they keep on tuning that up and trying to get the best out of it. That's right, no? Okay.
Yes.
Anyway, great effort. The fact that you made it to here is a big statement in itself, and we'd like to give you a big hand for your effort. And great job. So we're getting a lot of teams from the south. It's very interesting.
Actually, all teams are from South in at least NBP.
Yeah, that's very
That's
interesting.
just trivial fact about it. Yeah.
Good. So over to you, Andrea.
Yeah. Yes. So again, judges, please award the scores to team 2487. Good job, guys. Next team we have is 2487.
We are 497.
Sorry, I'm sorry. The team to award the score is 497, and the next team is 2487, which is from Madras Institute of Technology campus, Anna University. Now, this team has used distinct backup functions to tackle the worst case scenarios, such as when the ball hides behind the wall because of the perspective view. And they also have a different way of avoiding the first collision that happens when the ball is dropped on the table. So let's see their performance now.
Hi, I'm Saubhagya Lakshmi from MIT Anna University, Chennai.
This is Pooja MIT Anna University, Chennai.
Hi, this is Kavya from MIT Anna University, Chennai.
Hello, this is Yogeshwari from MIT Anna University, Chennai.
Initially, we weren't that clear on how to divide the works between ourselves, so we ourselves took topics on which we were comfortable with, and arranged meetings now and then. But after it, two of our teammates, mine and Pooja's computers weren't much compatible with the software, so we arranged meetings like daily 2 to 3 hours, and we sat together and coded together. And then we divided works. Saubhagya did Python coding, Lua coding, and image processing. Yogeshwari took care of the mechanical part, and me and Pooja contributed to the Python codes. After PID, there were some difficulties in our household call. Many of my family members got corona, so we got admitted at the hospital and all. We didn't get much net facility, so it was difficult to contribute at that time. And so other team members took care of the remaining coding and all, and they contributed now and then.
The major challenges faced by our team was PID. We found it really hard to implement the PID controller as the concept was very new to us. But with the help of Piazza portal and the resource materials provided, we could somehow understand it and implemented it and made our model working.
The next major challenge faced by our team was during the ball drop. When the ball is about to drop from the conveyor belt onto the table through the down pipe, the ball would have a high momentum which would cause initial deviations and collisions. So we thought of an idea and employed a hold and release mechanism which would work in a way that when the ball is about to drop onto the table would tilt upwards and the ball would get stuck inside the down pipe, and the table would come back to the original position, by which the ball would get released and the ball goes on to traverse its path. Another major concept that has to be implemented in our design was multitasking, that is simultaneous working of two tables. Finally, we used multi-threading module of Python to solve this. eYantra was not like a competition itself, it was completely a self-learning process. The consistency we had all these 6 months, we have never been this consistent in anything before. And also the mindset with which we approach the problem, the confidence with which we approach the problem, it gradually increased from the task 1 to the task 6. And the teamwork, the team effort we took, and complementing team members' work, these things, it was like a very fun learning process.
eYantra created a great impact for us. Now we feel really confident to take up any project, any work whatsoever, and we are not afraid of deadlines anymore. We know that we can accomplish any tasks given to us.
While designing the ball balancing platform, our main objective was to design a simple no vibration stable model. So we're very conscious about designing a model using less number of components but with good stability. Two yokes connected using a universal joint has been placed in the center to support the top plate accordingly during its movement. 4 servo motors have been used for the perfect continuous tilts of the plate with respect to the ball traversal, and opposite pairs of servo motor work synchronously in exactly opposite direction. The servo fin is positioned parallelly to the top plate for the easy calculation of the output angle. Since it is a 2 DOF platform, each pair of servo motor controls one direction. The servo angle is obtained for each axis separately using PID, and it is given to each servo motor in same magnitude and opposite direction. One special feature of our design is that we have used 4 servo motors rather than using 2. It contributed majorly towards the stability and also during the continuous tilts of the plate when the ball is traversing. Using 4 servos, the table cooperated very well with the code.
The ball is passed onto the conveyor belt by the ball dispenser. We have used a hold and release mechanism to prevent the initial collisions and deviations of the ball. We have made the ball traverse faster by applying a threshold instead of making the ball traverse to the exact set point. We make the ball shift to the next set point as soon as it is within a particular distance nearer to the set point. When the ball gets deviated from its path or when it is not found by the vision sensor, after few seconds the shaking function is called. So through this, the table is shakes slightly and the ball gets back to its position, and then the backup function is called. The ball finds its path from its current position to the actual endpoint and traverses through the path.
So that was team ID 2487. Now I request all the team members to get ready for the Viva session. Please turn on your webcam and I request the judges to proceed with the Viva. Thank you.
Batsperson.
Yes.
Leena and Paritosh.
I request Professor Paritosh to start.
PID for the first.
Thank you.
Okay.
Okay. So I think I will, something similar has been asked before. You're designing your system where the state of the system is given by the position of the ball, X and Y, right? They're calculated from that given the next set point. This is your approach, right?
Yes, sir.
Hello?
Yes, sir.
Are you able to? Yeah. In order to handle corners using thresholding, right? Where you switch the set point to the next one once you are somewhere near the corner, correct?
Yes, sir. Exactly.
We lost a bit of your audio.
Acha. I will try to speak slowly. Maybe that will help.
Yeah, just repeat the question.
So the question is, I can make the ball follow the same path by, at different velocities. Suppose I tilt very less, but tilt X and Y in the right proportion, the ball will follow the same path as when I tilt double the amount and, but I maintain the ratio between X and Y, right? So,
yes, sir.
So somehow velocity is not part of the state of the system that you are modeling.
But velocity is a factor for scoring time bonus, sir. The speeder the ball, the more points we get for that.
No, but when you calculate error, do you think it makes sense to take velocity into account when you calculate error? So you're using the sledgehammer thresholding as a kind of jugaad to handle that.
Yes. Yes, sir.
If you had to take velocity into account, for example, how would that help in your control? And how would you be able to do better?
Actually, we are taking velocity into account, sir. We are using the derivative of PD controller. We are not using integral part. We are using proportional and derivative controller.
Yeah, but what is your error term? What is your error term? How is the error calculated?
Yeah, the derivative term, it takes care of the speed of the ball. It makes sure that the speed is not too less or not too high. The proportional term, yeah.
I understand that. What I am saying is, how do you, to the PID controller, how do you give the value of error from set point?
Okay, so the current position is, we get the current position of the ball through the vision sensor, and we make the calculations and apply to the PD equation that we are using, sir. And then the PD equation gives the output as the angle of the servo motor. This happens for both the axes, separately for x-axis and separately for y-axis, and then we communicate the angle to the coppeliasm servo motor.
I think I need to explain my question a little better.
Oh,
so currently to the PD controller, before applying proportional and integral term, you applied to the different, to something called the error. That is, the target you want to reach and where you are, some measure of how far you are from the target, right?
I think I got your point, sir. The proportional term, it calculates the error based on the current position of the ball and the set point. But the derivative term, it takes care of the current position of the ball and the position of the ball in the previous loop. So we used a method called derivative kick for that, so that it is more stable and it avoids peaks in the graph.
So let me ask this indirectly. Suppose you had the objective that you want to design a control algorithm which will make the ball roll fast when you're on straight line, but when it approaches the corner, it will automatically make it slow down. How would you design such a controller?
Yes, so actually the PD controller equation will take care of everything, sir. Whatever you are telling, the PD equation will take care of all.
Your current design will slow down the ball when you are approaching the corner?
Yes, sir. Yes, sir.
Okay.
It slows down. The target for the ball is a set point, but actually the threshold, how it works is the ball will be moving towards the set point. But as soon as it reaches a particular distance towards the set point, it will shift to the next set point. The target remains the same, so that set point. And the proportional and derivative terms act normally. But as soon as it reaches the threshold, it shifts to the next set point. This makes a ball much, much faster.
Yeah. Okay, fine. I got some idea. I think we have to sort of, this is, I don't know if you understand what I'm trying to do. I'm trying to manipulate velocity also as a controllable aspect of the system. And the only way you can do it is by taking this into account by the modifying the error computation to make it sensitive to the velocity. But let it pass. The other thing I wanted to ask you was, what algorithm did you use to find plan the path?
We have used BF algorithm, sir. Breadth first search algorithm we have used.
I see. I see. Okay. Now this was asked to others also, right? That you know, you can have two paths with same lengths, especially when you are using Manhattan geometry. You know, one with lots of turns. You know, you move up 1 unit, move right 1 unit, or you can move 10 units to the left and then 10 units to the right. Both will have same length. Which path would you prefer?
We'll choose a path which has less number of turns, sir, actually.
So
But
how would you modify your algorithm to take this into account?
sorry, sir.
How would you know, your current breadth first algorithm will give, say both paths are of equal length, so both are equal. How would you modify the algorithm to take into account number of turns?
Okay, sir, but we didn't actually think about this. But the thing is, we actually wanted the shortest possible path. So since BFS is a queue-based algorithm, we only got the shortest path at the first. Since we had only less time.
I understand. I'm not asking why you didn't do it. Now that the question is asked to you, can you think now and say, you know, how would you modify the algorithm so that you choose, you know, a better path out of the two which are the same distance?
I would like to add a point to that, sir. So
Yes.
while when we are having a contradictory thing like that, we can see the number of set points in each path. So after calculating the pixel path, we can see which path has least number of set points, and that would obviously be the path with short turns, less number of turns. Yes, sir. But actually, we didn't implement that. We got the idea only after you said it, sir.
Yeah. Thanks for the honesty.
Okay.
Right.
Okay. Thanks.
So
Somebody else, please.
So Paritosh, you made them think about other options, which is nice.
Right.
Perhaps Leena has got another point of view that she'd like to put across.
Exactly, but I want to know, in the video, the presentation, you mentioned about vibration and how to reduce the vibration. Did you take some efforts on it?
Yes, ma'am. First, actually, we had only 2 servo motors, and we thought it was enough to control the ball traversal. But when we had the task to tune PID, we found that vibrations were like we found vibrations there, and we wanted to reduce We thought we were wrong with PID, so we continuously took efforts on tuning up PID, but we didn't get anything better. So at least for a try, we gave with 4 servo motors, and we found that there were no vibrations actually. So that's why we shifted from 2 servo motors to 4 servo motors.
Okay, one last question here. I would like to relate this vibration observation of your vibration with respect to the theory that we study. You must have looked into the step response. Have you studied step response in the control theory?
Yes, ma'am.
Because you are talking about PID control as well. So when we talk about the second order system, and second order system has what? Is it, I mean, have you studied the control systems? Linear control systems theory? Classical?
Not yet. We are in the second year right now.
I see. Okay, wonderful. So when you study this, relate to the oscillations that you receive from steps from the step response. Maybe others who are the participants in this would be able to appreciate that fact. So that's all from me. Thank you.
Okay, that's interesting. So I wonder if the board on which the balls move around is how rigid the board is, because if it's even if it's not rigid, it can cause oscillations. If it's rigid, also there might be some oscillations.
So Kavi, this is question to the designers of the simulator. What aspects of rigidity of the board did they put into the model? I'm
Yeah,
surprised that the
so
model is showing vibrations.
correct. So the board, as Kavi sir asked, is rigid. It's totally rigid. There are it cannot bend in nature.
So how did
So
vibrations happen?
so those vibrations are so it could be because of many reasons. So in Coppelia Sim, when you actually connect different objects, you develop a hierarchy, and it could be because of incorrect hierarchy. That is one reason, or it could also be because their control system is fluctuating. I mean, it's not
It's
able to
oscillating.
reach
It's
the
not stabilizing.
yes, yes. So that could also be one of the reasons.
I had a small point to make in this. Now, maybe for the game developers, designers as well, more to the participant, the contestants also. What if you take the central universal joint which is there and then replace it with a spring? The whole table is mounted on a spring and not on a joint.
Coppelia Sim would have to do much more work, I think.
No, I'm just asking what would happen, because there are many instances wherein it is mounted on a spring. The table is mounted on a spring, for example, the jig for that matter. So what would happen, or how would you go about changing your control algorithms and systems?
So if it was a spring, I don't think it would be a 2DOF platform. It will move almost randomly in all the possible directions. Since it is a universal joint, we can use 2DOF concept and use X and Y direction alone for our PID controllers. I think for spring, it would be really challenging to make the tables stable. And PID controller, to be honest, I don't know how it would, we should have done for that. For spring, it not be stable, I guess. It's almost
Of
not
course,
possible.
that is the challenge, right? I mean,
Yeah,
the
yes.
table mounted on a spring is the challenge. So the challenge is to make it stable and let the ball move in the correct direction.
Then I think the most in our current design, the most of the support is being done by the universal joint. In the case of the spring, the most of the support work would have been done by the servo motors, I guess, and the rods.
Okay, fine. That is something for you people to think about. All right, thank you.
Actually, I have an associated. If I didn't, sorry for interjecting.
Yeah, go ahead.
Since you have got four joints on four sides supporting the table, right? Can it take out the whole load, and why do you need the universal joint? Just remove it.
Yes.
Or rigid board.
No, sir. Actually, the top table is of dimensions 1 meter cross 1 meter. So the load would have been really heavy for the servo motors alone to
Okay,
balance.
good. Thank you.
No. But if the rigid board is very light, then you won't have that problem, right?
Yeah, yes, sir. Yeah, that's correct.
Okay, so Amit, do you have any response to that? Let's put the team designers on the mat now.
Yeah, so we actually had this thought, like, should we use a universal joint or not? Because in Coppelia Sim, as you are saying, if we reduce the mass of the board, the top plate basically, then the universal joint is not required. But at that point of time, we also wanted the students to make their design such that they can build them in reality as well if they are planning to. And not using the universal joint will severely increase the torque on the motors and reduce the stability of the design as well. So that's why we had asked them. So we had given them all these objects, all these parts, and they had to assemble it. So there were certain restrictions on the number of parts that they had to use, and that's the reason they use the universal joint.
So Lina, as you'll appreciate, one skill which has been evolving on the project over a period of time is how to design these things. So you pitch it at the right level and it's not too high and not too low and stretches everybody enough to provide a kind of, varied experience. That's been a challenge.
I will just simply give one applications wise. You have already mentioned about this one, so this is right time to mention this. This is a wonderful steward platform system, and I have just put that into chat window here. This steward platform is able to supposed to do the 6 DOF manipulations, right? The table manipulation. And this funda is used in the rocket stabilization. And it's a very challenging control problem. And the team designers, the problem designers here, I should appreciate that they have brought down the problem to a level where this can be at least being addressed through the PID levels. Wonderful job. Thank you.
Great. So big hand to everybody, including the students, participants, and the designers, right? Thank you very much. And I think this all-girls team has yet again shown themselves very well. We are getting lots of all-girl teams, and more power to them. And we are extremely happy about that. So I'll hand the floor back to our all-girl team here, which is Andrea, to move the show on. We are the last one here. We are running behind time, so we'll try and be fast here with this one. And then I'd like all of you to just think of something that you want to share, your experience today, your observations, to sum up what you believe that we experienced today to close the thing. And do remember, we have a photo up at the end of it. So over to you, Andrea.
Yes, so the next team we have, the final team, that is 350 from Sastra University, and this team used a divide by 2 mantra, where they used only half of the time allotted to them to build up the solutions, and then they selected the best solution from that. And even they have tested their code against all the possible available test cases which we provided, and also some test cases which they created on their own. They also have something called as a backup plan in case the ball detection was missed during the transition of the ball from the dispenser to the center table. So yes, so let's proceed and watch their demonstration.
Hello everyone, our team ID is 350 and our team is Nirikshak Bot. We are from Sastra University. Let me introduce our teammates. Our teammates are Sabri Ganesh, Sushmita Priya, Challa Sneha.
Coming to the work assigning part, we have assigned our works within ourselves as I took care of designing part, Sushmita and Sneha took care of coding part related to image processing and detecting the balls and all those things, and Sabri Ganesh took care of maze encoding, and after task 3 we all merged ourselves into a single task, that is tuning.
So regarding the challenges that we faced during the span of eYantra, we had many, but some honorable mentions are primarily the PID tuning was a bit of an hassle from task 3 because these values are really sensitive, and if you don't know the concept, it's easy to get lost. So it took us some weeks to get that to perfection. And the second problem was the usage of app along with Copiliasm, because at the beginning we didn't know why these errors come in the app, where do they pop up from, and then later we realized the cause of it. So those were the technical challenges that we faced.
Yeah, the learning outcomes of eYantra are: we have learned how to apply the concepts learned in eYantra in the real world problems, and also we have learned how can we get a good communication skills when we are into our teams, and also we learned time management skills also. And major part in this is we learned how to tune a robot or something using the PID tunings.
Coming to the ball balancing platform design, this is a ball balancing platform which we have used for the whole team run, and here we can see that the top plate is connected to the servos with the help of L connectors and connecting rods, which will help in the movement of the top plate with respect to the values given in the with respect to the movement of the ball, so that we can see that universal joint is given as a support to the top plate, so that if the ball weight is increased, then also it will not be collapsed. Yeah, coming to how we have designed the ball balancing platform, in the sense we have learned about the each and every part given in the eYantra portal and where we should use in the design from the internet. For example, we have learned about yoke, how to use the yoke in the ball balancing platform, so that we came to know that we should use it to get a two-dimensional movement for the ball balancing platform. Similarly, for every part we have learned what is the use of that part. Finally, we merged all the learnings and came up with this design. Coming to the part of algorithm supported by the ball balancing platform are, we have used Lua in customization scripts of the ball balancing platform, in which we have written a code for generating the mazes on the top plate, and also we have used the Lua script for deleting the mazes which were generated after the stimulation is completed, and also we have written a Python script which can control the ball on the top plate using the images generated by the vision sensor.
Finally, we have established a connection between the Lua and the Python using the remote API functions which are mentioned in the CopiliaSim help files. These both functions will work coordinatingly, and the ball will be traversed from the starting point to the ending point with the help of the both algorithms in Lua and Python.
Enter the credentials in the app and we have started the simulation, and the images are generated as per the images. We are using Vision Sensor 5 to collect the color of the ball so that we can design upon where the ball has to traverse. And regarding the traversal of the ball, you can see that it's pretty fast because we had indeed prioritized speed over collisions. Because truth be told, we thought the end final mazes will be really tough, but we didn't want to make any last minute changes, so we thought this code was robust enough to handle. So regarding the starting collisions, that is the collision when the ball is being dropped, we had included a sort of algorithm where we decided to use geometry. What we did is we had tilted the top plate in angle so that it won't be the ball won't be released out of the maze until the vision sensor has detected a ball on that particular table. So you can see that there are no collisions at the beginning of the traversal, that is when the ball is stopped. And regarding the traversal at the endpoint, after reaching the endpoint, we simply used an algorithm where we gave a certain angle after the traversal so that the ball will move to the next maze. Up to this point, the collisions were minimal. This was the ball which caused us most collisions. As I already said, as we had prioritized speed over collisions, we had given more error range. That is the point at which the ball has to change from one set point to another. That error range was widened so that the ball will move faster. But it did cost us some collisions at the end. But we didn't want to make any last minute changes.
So this was team ID 350. I request all the team members to get ready for Viva session. Judges, please go ahead with the questionnaire.
So different approach here to collisions. But collisions are okay as long as you have speed. Paritosh?
Maybe somebody else should, but I can. Yeah. So how did you decide at what speed? I mean, how much tilt to give? Trial and error?
Sir, Sabri Ganesh can answer this.
Yes, sir. Basically, we had a maze which is pretty difficult than whatever we got in the finals, which is something we were given in the some other task, which was really difficult to navigate. Like it took 80 seconds or more for the speed which we are going on. So we raced, kind of trained our ball, and we kind of thought that this could be the most worst scenario that we could get. So we trained it in such a way that the speed we have trained in such a way that it could complete all the balls at minimum time. It's not trial and error.
Now, within your solution, suppose we take your solution as the starting point and we want to modify it so that the number of collisions get reduced. What would you do? How would you modify your design?
Yes, sir. As we said in the algorithm, we have a certain error range so that the ball changes from one set point to another. If we reduce that error, we can surely reduce the collisions too.
Error range is with respect to what?
Error range is with respect to the changing of set point. That is, if the ball is in the ball has to reach a particular set point, say, while it's reaching, the moment when it has to change to the next, when it has to start traversing the next set point, we have given a particular error range, that is the difference between center of the ball and the set point. So we have given some 90 or 80 pixels for that change to occur.
But collisions can occur even on the path, before turning, right? You can bump into the wall while you are driving, right?
No, sir. We tried that also. Mostly we try like if we change the KPKD values such, with accordance to the error range, we are definitely getting minimal collisions.
Okay, that's fine. Are you electrical engineering students? And have you done a course on control theory?
No, sir. None of us are electrical students.
Okay.
Also, another point, which 2 points I would like to add, which was not there in the video. The first thing is we have used a kind of a mathematical solution because the view we are using is perspective view, not orthogonal. So
Okay.
to check whether the ball has reached the correct set point, if it's a uh, perspective view, we cannot directly give the point value to the feedback. So we used some mathematical functions there. And secondarily, as ma'am already
What
said, we
kind of
have
mathematical function did you use? Did you use something from OpenCV?
no, we created a mathematical function ourselves, which is fairly simple. The thing is, if the ball is further away from the center, we are kind of projecting it to be nearer to the center, which helped us uh, come up from the barrier, that perspective view barrier. So that also helped us reduce collision when the ball was away from the center.
So in reality, of course, you will not have this kind of perspective view. Perspective view is only something that an artist draws. You will have homotopy. You will have orthographic projections, right? Have you studied little bit of how from an orthographic view, projection view, you can actually derive the real coordinates?
Yes, sir. Yes, sir. Actually, that would be a simpler case for us than perspective view. But we are allowed only to use perspective view in the
Okay,
simulation.
fine,
So we went
fine,
with some mathematical functions to deal with that.
fine. Yeah, Kavi, I think I'm done. I think others should ask. I've been asking a lot.
Yes.
Yeah.
Satish, Lina. I think Kriti is also there.
Yeah.
Lina, are you there? Ah.
Yeah, I'm there. Maybe Professor Satish and Kriti can
Yeah.
start.
Okay. Since you said none of you are from electrical engineering, what disciplines are you from?
Computer science, sir.
Sorry?
From mechanical engineering, sir. The girls are from CSE department, and the another boy is CSBS, sir, Computer Science and Business Systems.
Okay, fine. Okay. So I just wanted to computer science and mechanical engineering. So if you want to do machine design, and then I just curiously, I wanted to ask you this question. So what if you take out this central joint and then put a spring there instead?
Yes, I would like to answer this. In the design, if we include the spring without including the universal joint, we should also change the servo, the rods which were used to control the table. Only if the spring is in the, if you use the spring, the problem is we will have so much compression in the table. We can say that from a maximum height, it will compress to minimum height when the ball is forward. So it would be a hassle to use the spring design and also control it with the use of servos.
Okay.
To add on to that point, actually, there was a restriction as to that we should use the yokes. So we thought of not having yokes and manage with 4 servos, so that we can have some control over the height of the macer. So that was our first plan in reducing the starting collisions. We thought of increasing the height somehow, so that we can reduce the starting collision, so that the ball will be trapped in the down pipe. But then we came up with the solution as to increasing the angle. So that was always there in our mind, that to ditch the yoke and use some 4 servo motors. And the most we researched, the, the more we researched, we came up with different perspectives as to how we can implement these mazes. And we found out more implementations where they were using arms instead of just servos and rods, and there were more functionalities also. So if we
Okay.
are given an opportunity for
Yeah. So one other question that I would like to ask you, suppose the 4 servos which are there, which you are using, you're basically, if I understand it correctly, the 2 opposite servos are linked with each other, correct?
Our model is just 2 servers model, sir. We're not using 4 servers. We just
Oh,
thought
you're
of
using
using,
only 2
yeah,
servers,
yeah,
not the 4
no,
servers.
yeah. We found
Okay.
out the opposite servers were redundant somewhat, and they're limiting the movement. So we went with 2 servers.
Okay, that's interesting. Okay, fine. So you said using 4 is limiting the movement of the ball. So you went ahead with only 2 servers. Okay, okay, fine. Yeah, yeah. Lena?
In fact, I'd like to make an observation, Lena. This is an interesting point that if you remove that central pivot, then you can adjust the height of the thing. And this is a nice idea that you raise the thing to capture the ball and then get on with the whole thing. And plus, it would give you much more mobility.
Yeah, that's right. But at the same time, the degree of freedom will increase and the complexity of the problem increases. Yes.
Yes.
So,
Kavi, soon you will be in the lunar lander, which crashed. Instead of these joints, you will have thrusters.
Yes.
That's what she was driving at. No, very
Yes.
relevant
Yes.
point. Absolutely brilliant.
Yes. Yeah, Lena.
okay. So I will go with 2 quick questions. One is about the perspective projections that you were talking about, the mathematical function. Is the mathematical function, I don't know what function you have used and what not, but your claims are that it's working, right? So do you want to comment on its one-to-one mapping or or it's a bijective map? And that is why perhaps it's working. I'm trying to connect you to the theory, what you study in your 12th or some in the first year maths itself.
And interestingly, they said orthographic projections would be simpler for them.
Yes,
Which I
that's
think
fair.
is
That's right.
yeah.
Yes, it has worked wonderful, absolutely. But will it work in all the scenarios? What could be your intuition? You might not have tested for all the possibilities given the time constraint, but what's your intuition and gut feeling? Or the projection map, at least the functions that you have derived, can you comment anything about its one-to-one mapping or something like that?
No, ma'am, we didn't go that far in terms of theory. We didn't like we didn't know what problem lies in front of us, and changing from perspective view to orthographic view graphically it took more time than using a mathematical function. So we sort of did some jugaad in coming up with the mathematical
No,
function.
that
Uh,
jugaad works. Doesn't matter. But one has
yeah.
to have the idea that it will work in all scenarios or not. Correct?
Yes, ma'am. We are sure it works in all scenario within the bounds of the simulation that we are given. Uh, but as you said, there may be more theory onto it that we don't know.
Okay, okay, no issues. The second part that I want to comment on is that you allowed the collision to happen. I'm sure you have trigged it because there were no points on the impact of the collision. So you allowed, yeah, is that right?
Yes, ma'am. At some points we allowed because as we already said, the mazes we were training on previously, they were really difficult. So our priority was to complete the run rather than
Right.
like we can manage 2 balls simultaneously, but computational power and efficiency wise it was somewhat bad, and collisions also increased when we were trying with 2 balls. So but if we knew previously that the mazes would be somewhat less difficult than what we trained with, we could have tuned it properly and came up with a zero collision model.
Okay, okay, no issues. So here my question here is the speed at which it is colliding, that doesn't matter to you, right?
Yes, ma'am. We didn't
Points
take
were
that
not
into.
given on the
Yeah.
impact,
No, ma'am. That wasn't given.
right? And you have been given certain test mazes. Were you able to do on all the test mazes?
Yes, ma'am. That was working. We basically we trained for the most difficult and worst case scenario. It was working for all test cases.
So training was based on your trial and error method again?
We kind of shifted the values of KPKD and the error range as to where we changed the thing, increase the speed. And these are the things we kept in mind, but it is kind of trial and error when we are reducing and increasing the terms.
Okay, all right, fair enough. Thank you so much. That's it from my side.
Thank you, Lena.
One thing
In
to
fact,
add on, ma'am.
yeah, go on.
We have penalty for each collision.
You do have penalty for collision, but at which speed it is colliding, the impact.
Speed was not a matter, but
that is not point. The points were not based on that, right? The gradings of the points.
Yes,
That is what my understanding. Great.
Yeah, Lena, in fact, first of all, a big hand to this team before we close. Right, great effort. But a lot of interesting points have come out of this whole thing, right? Lena, as you've quite well observed, generally what happens in the competition because of the shortness of the time in 6 months from beginning to end, right? They have to race through it. They do jugaad, they make the thing work and come to the finals, right? But in the process, especially at this point when they are faced with the jury and are asked about the deeper understanding of what they've done, I'm sure it sensitizes them to the whole notion of theory, right? What is the theory behind all this? What is the systematic way of making a choice rather than ye chalta hai to let's just run with this? How to explore the various options? Is there a better way to do it? We often find that teams begin to start thinking about these things here, and it's quite satisfying to see that. And now what's happening is because we are live streaming this on YouTube, there are a bunch of other kids who are kind of very critically looking at this kind of engagement and questions and stuff like that and learning from that. And we find that as a result of this, what's happening is each year the level goes higher and higher. So something is happening out there, right? But we do recognize the need to add more theory, but that would make the thing a bit longer. But we are actually working on that. And we'd love to work with now the faculty at IIT Bombay to see how we can systematically introduce theory into all this uh, uh, in a way that also helps them compete. So this is a lot of project-based learning. A little aside here, you know, we've done this with school children.
Kavi sir, we lost your feed.
Yeah.
In the meantime, I think Preeti sir had a few questions to ask. Preeti sir, are you there? Hello. Yeah, we can hear you, sir.
Saying that textbooks are not something that you pass exams with. These are manuals with which we live our lives now, which is very exciting. It's like Harry Potter's book of spells. You know, once you have these spells in your physics and geometry book, you can actually do some cool things with it. And that's been very satisfying for us and an eye-opener. But what I would like is if each of our jury members can just sum up their experience today and give a sense of closure to our young participants here as to what is your impression of
Sir, I think Preeti sir had a couple of questions for the team.
Yeah, Kriti, you got some questions, and then maybe you should lead with the summarizing. Yeah, Kriti, are you there? I think he had a network problem.
Yeah, I mean, I can see him logged in.
Yes, he had a network problem. So maybe Paritosh, I'll start with you maybe.
Okay, sure. So, firstly, I must actually congratulate all the finalists for reaching this far. There are many skills that you have learned, handling this complexity of, systems and integrating things is, learning different skills, right from control theory to, modeling things within Coppelia Sim, learning languages like Lua, and then also Python, is a lot to handle, and that you have been able to put all this together and together a working prototype is all you. I don't think I could have done it so easily. So great work, guys. This is first and foremost, and that ability to understand the problem and try to put things together to make things work is important. as you must have seen, this would have required you to model a little bit of mechanical, systems, including different kinds of joints and members. Also deal with a little bit of control theory, little bit of 3D geometry in order to adjust for camera view to, actual physical positions in reality. Then there were some computer science algorithms. So you see, I mean, a problem like this tells you that problems don't come in electrical engineering or computer science or mechanical engineering. Problems are problems. And one of the banes of our current day education is that we only teach one discipline, whereas this is your chance to see that world is more integrated than that, and we should have much more wider thinking. We should be able to think from first principles, and be able to create our own solutions, and that you have been able to do this is commendable. So that is my first point. It's also good that this way you learn to talk to your colleagues in other disciplines. You form teams which are multidisciplinary, and I think I have been associated with this eYantra competition for many years, and I've seen that it is teams which are multidisciplinary tend to do very well. So that is one. Second thing I want to do is, most of the solutions have been done. You've been given certain recipes. There is one kind of controller called PID controller, and you are given this simulator which tells you how the table behaves. Actually, there is a lot of theory that goes behind this. So as Professor Kavi Arya said, we learn to do things by jugaad, but that arouses our curiosity as to what goes behind these things. And let me tell you, at some point, jugaad stops working, and you have to fall back on the science behind these things. So there is a lot of physics that goes into modeling of those rolling of the balls on surfaces. There is the table. There was this talk of what kind of joints support those tables, whether they are springs, whether tables have rigidities. Also, balls may not be perfectly spherical. Their masses may not be perfectly fixed. When you manufacture balls, they come with certain amount of uncertainty. So actually, you have to control systems under uncertainty and disturbance, and that is one thing that sometimes doesn't show up in simple simulations. And real world is much tougher than what you simulate. Simulation is your first cut to the problem. So I would like you to appreciate the difference between simulation and real life. When you go to real life, you will have to build what is called a robust controller. And for that, you will need to understand a little bit deeper mathematical aspect of this, the theory behind the kind of systems that you are building. Third thing that I would like to tell you is that, this you should have curiosity about, suppose this simulator was not there, and you have to write down mathematical equations which tell you when you tilt the board by this much amount, how will the ball move, right? There'll be simple laws of motion with some geometry thrown in, which will let you move this. But soon you will find that those equations get completely out of hand. You have to discover interesting ways of approximating the problem to solve it. So there is considerable work that is required here. Your mentors have done all this hard work of modeling that physics, but if you actually try to mimic that physics, you'll find this system of ball balancing table are quite complicated. It's a nonlinear system, and to accurately model it in physics and solve it analytically is not so simple. So there is much that you can study around this problem. This is what I would like to say. And if this problem has aroused your curiosity, try and read some papers around ball balancing tables. You'll find some interesting stuff. Okay, I think that's what I would like to say.
Thanks, Paritosh. So you pointed out the limitations of jugaad. When you reach the limits of jugaad, that's when you start to need to appreciate theory. Very good point made there. I'm going to first ask Satish, then Purba, and finally Leena. I'm saving you for the end.
Yeah.
Right?
Okay.
So this is the first time. This is the first time you've been jury on eYantra, and I wondered if you had heard about it in the past because it's been around for some time.
Yes.
And I wondered what your perception was and what you've experienced today.
Yeah. Okay. So I think since you mentioned that particular point, let me be very clear. This is the first time actually I have been part of this particular exercise of eYantra. I have been seeing signposts and labs, everything being put in the campus. On and off, I've come across, but I never really knew what was actually going on. So this is the first time I'm actually experiencing what everybody is doing, not just the team Yantra, but even the competitors and the organizers and the hosts. They are putting in a whole lot of effort into doing this. So that was a good part, and I'm very glad I'm part of this particular exercise that you are undertaking, Kavi. So the interesting things that I noticed is first and the foremost, I see that you are students right from the second year onwards up to the fourth year. So it is very gladdening or heartening for me to see that even a second year student who doesn't have much of an exposure to so-called engineering is still enthusiastic to participate and learn from this exercise. And that is very, very important, because the earlier you start, the earlier you raise your curiosity so that you can learn and go far, far higher. As Professor Paritosh Pandya was mentioning, Jugaad is not the thing that one should rely upon, but one should really learn it in the proper way so that you can take it too far away. Okay, so that was a very interesting thing. And see, that was one of the reasons why I was asking you people. I think one or two teams I asked, what is the composition of the team? Now, what happens is when you're sitting with a particular stream or a design or a curriculum, you only get that particular perspective. So, but when you start interacting with other people, other disciplines, especially, you get a perspective which is very different from what you are doing or what you look at it from a limited perspective. So that is also very interesting for me, that I could see people who are part of physics to electrical engineering to computer science and control systems who are all part of this particular exercise. This is very good. So that is another biggest plus point that I see today. Then the other thing that I would like to tell all the contestants is it's a tremendous work, and you people have really done a wonderful job. Whether you become a finalist or not is not important, but the spirit of participating in this particular event is something which is very, very good. But what I would suggest and request to most of you is, like what was being said, you're given quite a lot of these particular solutions in a ready-made fashion. Okay. Now, like what was mentioned earlier, the world outside is not ready-made, and it doesn't have solutions which are coming ready-made. So that's one of the reasons why I said, what if the ball is not spherical? What if it is elliptical or ellipsoidal for that matter? What if there is friction on the table which is varying from point to point? And what if the central support is replaced with a spring? So these are many systems and many variations and combinations which are possible. And I think you should take this as a starting point or an exercise to go out and explore yourself in the world outside with real examples. See, one of the things that I would like to mention here is that if you look at the current scenario of talking about COVID and the pandemic, the most important thing that everybody talks about is the vaccine. Okay. Now, if you look and think about this particular vaccine, these are vials of liquid filled in a glass bottle, which are produced by millions and hundreds of millions in quantity. And if you look at the production plant for that matter, it really is amazing to see these bottles going in a conveyor belt or a chain in an extremely high speed fashion. Now, if you want to take this example of a maze table, and if I want to extend this logic to this particular vaccine vials, which are going around these particular assembly tables, if suppose one vial, for example, because you're talking about a mass, one vial has got 2 ml less, so that the weight is less, it immediately has to be flagged and then moved to a different section of the maze table. So you can look at this particular maze table as a starting point for you to explore various other options, and I think you should take this as a starting point and then sort of extend this particular logic to various circumstances that you can think of, including people talk about self-driving cars these days. So if you're going to be sitting in a control station and say, okay, fine, I'm going to let my car navigate through the maze of, for example, the Bombay city traffic, for example. So how am I going to accelerate and decelerate? Where am I going to get a turn? And how am I going to reach my end point? So this can also be extended into a sort of a maze table for that matter. So there are plenty of real life examples that you can think of. And I think you should take this as a starting point learn the deeper physics and the science behind the whole thing and start using it in reality. So the good thing is, I'm very happy to have become part of this, and I'm equally amazed and very glad to see that girls are also equally participating in this. And big hats off to all girls teams who are part of this particular competition. And it's very heartening to see that you're all part of this and you have no hesitation to be part of this particular activity. I think it's really commendable and great. And all the best to all of you. And I'm sure you will end up doing a great deal of things in future. All the best to all of you. And thanks a great deal for making me part of this.
Thank you, Satish. Wonderfully said. And I think the very nice observation that this is the starting point. And the great thing is that they've reached a starting point. Typically, the education system doesn't deliver them up to this starting point where they can actually do something cool, right? So we feel that now they're at least at a point where they can do something very real, and then the journey starts. And as you said, that in real life, the maze might not be constant, it might be varied, right? It could have various kind of imperfections of various kinds, which they'll have to adapt their ideas and theory and all that to. Very nice point. And also appreciating students across the years who are taking part. Thank you for that. If Kriti is here, I'd like him to just unmute.
I'm here. Can you, what should I do? Am I heard? Can you hear me?
Yes, you are heard.
Okay. I want to mention a couple of things which are, in some sense, repeating what others have said, but I've been meaning to say this for a while, so I don't feel bad about repeating it. First is that, what do you do when you have a problem that you want to solve? What do the teams do? Do they go to the professor and ask questions, or do they ask the librarian or their friends in your own institution or some other place? What do people do? I wonder about this because generally speaking, the feeling we have about our professors in our colleges is not very high, right? They think that they don't know what they're talking about. They wouldn't be here if they were good. Things like that. So my feeling is they probably don't approach their professors to ask questions and get them clarified. So this is one major problem that I believe. I may be wrong. I hope I'm wrong, but I don't think so. So that's one thing. The second is that when you have a problem, the chances are the others have the same problem. So a problem that you have at this level of education in college or in master's programs are indications of future PhD problems. And I hope that eYNTRA is doing its job right, because if the number of PhDs doesn't increase because of eYNTRA, that's to say, making people think about problems. This is what Satish also mentioned this now. If people don't say, here's the nature, here's the problem which is very important, it's hard, it's worthy of a PhD, I'm going to continue my studies beyond what I've done so far, I think eYNTRA has done its job. If that doesn't happen within the next 2 or 3 years, and I hope it's happened already, then we have a nice pipeline of problems and solutions to work on that will make it make the eYNTRA's approach to making people think work out. Okay, so what I'm saying is that don't be happy with just doing a bachelor's program and going away and working for some IT company. It's okay, but most of you are eYNTRA devotees, eYNTRA graduates, so you have to be doing more than what others do, right? Kavi, you want to emphasize this, I think, at some point in your going away. I lost me. Ben?
Yeah, now we got you back. We got you back.
No, sir.
So it's a very important point, but do continue.
I'm saying that we have to make the point to the students that what they're doing now is all great, is all wonderful. They're learning something out of it, but the overall goal should be much higher, much harder things should be aimed at, and only then we have done a job right. Okay? So this is what I want to mention. If you can do that by making students write a little report or a what's the word for it? A feedback form. I don't want to use it form. I don't want to make it a closed box kind of approach to getting feedback from them. I want them to think about this in a heartfelt way, whereby they say, here are things that I did which make me a different person from what I came in as, or what I'll end up doing in 5 years. Okay, that recognition will make them go places beyond what a normal BTech student would do, bachelor student would do. So this is what I want to see happen. The more of you go for doing your degree, either here or somewhere else, come back home and do it and apply that to local problems. Because directly going from eYantra problem to a local problem is hard.
Yeah. Kriti, may I respond to that now?
Yeah.
So I'd said that earlier in the breakout meeting, but interesting things are happening in the sense that students are taking the skills that they've been taught in the eYantra competition, and some of them are actually doing startups, right? There's a startup in drones, there's a startup in building sewer cleaning robots, there's a startup in building mobile robots. In fact, we have built an agricultural research platform, a mobile platform with a universal robotic arm, where the mobile robot has been sourced from one of our own students who's started a company in Coimbatore, and we've sourced that Muthu Vangaliyappan. That's Muthu Vangaliyappan. We've sourced the mobile bot from him. So we've always maintained to our students that you should, if you have the ability, you should either do a higher degree or you should do a startup. You choose, right? And we'll help you do either of those things. And I'm very proud to say that any people from the competition who've come to us for internships, first of all, the internship projects they've been doing with us have been really amazing. Many of them have got turned into publications in quite decent journals and conferences. We have pages of these kind of publications now. And we've been finding that they come, join us as project staff, work for a few years, then do an MTech at IIT Bombay. And those numbers are increasing. Right? Every year, 4 or 5 of our staff go and do an MTech. In fact, to us as interns, joined as project staff. Rutuja, for instance, is doing a PhD, and her area of interest is model-based design. We have Simran, who's doing high-performance computing. We have Lohit, who's looking at the communication stack of an agricultural robotic system. And we have Avinash, who's doing a PhD in control systems. So there's a lot of cool stuff happening. And in eYantra itself, we have divided ourselves into research verticals, in which it's an entire food chain which terminates in a faculty at IIT Bombay. So you have faculty, PhD student, MTech students, project staff, interns, right? So we are trying to build that entire ecosystem of innovation in eYantra itself, which is based around all these students from the colleges who take part in eYantra. We are trying to grow the base of this pyramid. So that's my response to you, Kriti. It is happening. And it's very exciting that it's happening, and we'd like to talk more about this with you offline.
Yeah. I'm not saying we're not doing it. I'm not saying we're not doing it. We should make sure the students know that there are opportunities beyond the eYantra, which they should pursue with rigor as soon as they finish their regular degree. So I'm glad you're doing it. I know you're doing it, but I just want to mention that this is something we had explicitly aim to achieve as a goal. Increase the basis. Okay, so wish everybody the best of luck. I'm very excited by what's happening, and we'll have to say that there's a long way to go, but we are on the right path, and with all of your be participating in this exercise in the future, we'll get there. Thank you very much.
Thank you, Kriti. It gave me the opportunity to say something. And thanks, Kriti. I'd like to give the floor to Purba. Unfortunately, we didn't have any design component in our theme today. Otherwise, we'd have had some more kind of questions from her. But Purba is from the design space of IDC and IIT Bombay. But I'm sure that she has her own observations about this. And we'll make sure next time to have more design elements in the theme, because that's extremely important in the real world out there, right? Designing products and systems and services. Purba, over to you.
So firstly, thank you so much for letting me part of this. I think it was more of a learning opportunity for me than actually judging. And like last time, there was a physicality to the ideas, and I think I could contribute more. But I'm hoping that once these ideas are taken further, I might be able to help with my inputs on the physicality part of it and the products and the systems part of it. To the students, I want to say that congratulations. It's been a really good efforts that I saw today. And like Professor Satish very well pointed it out, how the real world situations are very different from the theoretical things. And in design, we always emphasize the importance of learning by doing. So unless you do things, unless you try things, the learnings are very different. And in that, you should never be afraid to try things, because even failures teach you a lot than just the success. So my advice to all the students is test it out. It's very different when things are not theoretical. So this has been a lot of learning for me. So thank you for that. And thank you, Professor Kavi, for giving me opportunity to learn this time.
Thank you.
Yeah.
Thank you. So we'll move on now to Lena to close the show today. So Lena, maybe.
Sure, Professor Kavi. Thank you so much. And I was opening and closing Batman. All right. Okay. So as I will only speak about what others have not spoken, perhaps, because it is wonderfully summarized by Professor Paritosh, Satish, and Kriti, and as well as Purva. What is commendable here is what we have been able to achieve in the pandemic situation as well. From the point of view, from the problem design to reaching out to the students, and from the contestants perspective, how they formulated the team and how they have achieved it in the e-learning mode here. So that's all my closing remarks are. And congratulations to the entire team and contestants. Thank you.
Thank you very much. Short, concise, and very, very appropriate. I think these are very important remarks which have been made. A big hand for the jury and a big hand for the entire team who's made this happen. We have Abhinav, Avijit, Kalin, Amit, and Andrea, our team members. Would you please unmute your videos, all of you, our team members, plus the rest of the audience? We'd like to have a photo up. Aditya, would you please do the...
Sure. Sir,
But I'd like to announce
yeah.
YouTube winners, Balaji Bhargav and Priyabarta Saha, right? They've won goodies in YouTube. And I'd like to also announce that our software foundation course, the last day to register is the 4th of April, right? This is where we teach the students open source software and system design and stuff like that. So if you can just unmute your video, we'll take a picture. And we'll all pretend to be happy.
Yes, sir.
We request all the finalists to, all the finalists.
Everyone.
Good Friday today.
Unmute your video, everyone. Yes.
Great. But I must really appreciate the fact that IIT faculty who are, it's very difficult to get 20 minutes from them or half an hour from them. They've taken the trouble to be with this audience, with the students for almost over 3 hours. And I'm a bit embarrassed to note the amount of time, but Leena, Paritosh, Satish, Kriti, Purva, we really appreciate this, and you're doing it for the students, and I hope that we've made this investment of your time worth your while.
Can I send you a bill?
Certainly.